Mic better.
About no, actually, it's a lot. It's better. I would say I was about to say about the same, but no, it's better. It's better.
What if I say what if I clap? Can you hear?
No,
A B C D E F
no, no,
G.
I
You
can't
can
hear. If
hear?
you're clapping, I can't hear it.
Okay. Walt. Y B C D E F G H I J K L M N O P. Can you hear anything?
No.
I'll keep it like this then.
Okay, nice. Whatever you did, congrats.
I
Twinkle,
wonder what my
twinkle,
parents think I'm doing
little
clapping.
star.
Okay, okay. Let's focus a little bit. So we're gonna work on adding the primary key stuff, constraints. That's
No,
that's
no,
the
no.
goal, right?
Constraint. Yes. Constraints which happen to have primary keys as
Yeah.
one of them.
Okay, so
So
I mean, explain to me what it is in terms of
can I
ideas.
where we're adding a we don't have a folder with samples, right? I'll make one here.
Yeah, we don't have a folder with samples.
Samples. So let me make one in
Actually, I mean, it depends on what you mean by samples. Are you saying like, do we have tables or schemas? We do have that.
I'll type SQL, whatever.
Okay, SQL.
So here, I'll type sort of a SQL server. Uh, so when you make a table, you can make a table like this for a person, let's say. And then you probably would want to do age, integer, um, no, no,
Actually, I think
name.
that's gonna be the default, no? I think it's gonna be impossible. We're not gonna allow you to have null stuff, right?
Just a sec. Whatever, something like this, whatever. Uh, in this case, let's put a value here. Let's because you can't make an arbitrarily large value. So let's put I don't know 64 whatever. I work on base of 2. And then you would have like a primary key, some BS. Okay, that's a terrible primary key, I
Oh
know,
yeah,
but just
that's terrible.
just think of it. Just think of it. It's the same name. I don't know, man. ID, uh, document,
Ah,
number,
you're
something
not
like this.
laughing, Marinho, because you were not in the talk about databases. But
Document.
you literally said, Mageta literally said during the talk, you should never do this, and then he's doing it here.
Okay,
Okay,
are you
I
happy now?
yeah, I actually I didn't catch the live talk.
Oh,
And the
it's
video
not
is not
good,
up
man. I
yet.
think I should do
So
another, but with better content. I know more as well.
No, you should do another, but that was not previous one is not bad for sure. I guarantee you it was very educational.
Yeah, okay. I'll take for your word for it. So anyway, like this would be better. I mean, age you can probably remove from here. Name I don't see any reason to not have it, but for the simplicity, I'll just do this.
Uh huh.
So this you have a custom type here that like has a mask, I don't know, whatever, that has some ID for some random country, whatever. And then you have the Brazil CPF,
Yeah, yeah, yeah.
or something like this. So anyway, just think of this, okay?
Mhm.
So one of the things uh, that matter is the primary key, right? That's what people associate with constraints. But constraints they are anything that validates integrity in the data. So for example, here one constraint is this: check age greater than 0. So there's nobody with negative date, negative age, right? It makes no sense.
uh, but there are people who are 0 years old. So
Okay, that's fair.
Yeah. So that would be an example. And by the way, these rules they derive uh, from your domain of discourse, right? So the domain of discourse is basically what makes your uh, propositions to be true. So uh, that is what perspective of the world you're looking at. Otherwise, the constraints they don't make sense, right? They're just like Arbitrary rules based on what? Like it's whatever you want to express in the system, right? So
Yeah.
basically, this is the thing we gotta do. A predicate that needs to evaluate necessarily to true, so or false, like it evaluates to something, and then it asserts that this insertion to this table is permissible.
Okay, I do have an idea on how to do that. I do have. I don't know how
Okay,
cursed it is, but I do have an idea.
okay, but let me discuss what I have in mind for primary keys.
Go on.
This checks. Think about this. They are domain based, right? They can be domain based. So in this case here, it's self-contained, right? I'm just checking age. So
Mhm.
if this value that I'm inserting or updating right now, it needs to be greater or equal than zero.
Mhm.
But think about something like this. I don't know, something. Let's suppose the ID needs to be something like this. Let's suppose it's just a varchar, whatever. So the age, so the ID, the document number, needs to be equal to the name. Oops. So let's suppose that it's fictionally the name plus the date. Uh, now, uh, minus age, something like this, whatever.
Yeah,
Some
no, yeah, that makes
calculation.
sense. Yeah, I understood what
You
you're
got it.
saying.
So if it's a derivative of other data you have, right?
Yeah.
Uh, then you have to also use based on this data.
Wait, I have
That
a
is
question.
still go on.
Okay, so let's suppose that you remove this crap. I want to know what the heck is gonna happen here now.
Wait, which crap? I didn't see you removing
Okay,
anything.
The
Control
not
Z.
null. It removes the
Okay,
not
let's
null.
suppose you see the not null there.
Yeah.
Let's suppose that I do this.
Oh, the not null is by itself a constraint
I
as well.
understand that, but my question is, apparently there is some sort of like dependency in constraints because if this is not null, how this is gonna work?
Well, it will fail because you will if you get you can I mean, this will work as long as so long as you have the age. If you have allow null, then this will fail, right? Although
Uh,
I don't know, it depends on how you see strings because I think strings can be comparable with nulls in SQL Server. I'm not
yeah, we
sure.
are getting to very deep shit. Like,
Yeah, but that yeah, but that will depend
Uh,
because I know that nulls, like for example, unique, right?
yeah.
Why is unique different than a primary key? Because unique, uh, it validates field by field based on nulls as well. Primary keys they cannot be nulls. So because that the goal is eliminate this issue. So if you compare two rows that are like nulls, they are different. Like this is different than this. That's stupid, but yes, that is the idea of null, right? It is, which makes, I mean, it's stupid to have nulls, but it makes sense because nulls they are
no, it doesn't. It completely breaks your equality algebra.
no. My point is, it's three value logic, but the nature of null in logic in logic like Prolog, for example, then what's the point of nulls? They are false values, right? So they are predicates that are false, and that is you cannot evaluate to something true that is a fact in your database. So in other words, it's just lack of data. So that's the point of people adding nulls on SQL all the time. It's just lack of data. We're not gonna add nulls, by the way. I'm just giving an example, but
Yeah, I thought we were
uh,
never allowed to have
so
nulls.
yes, you can compare nulls because the point of them is okay. You're comparing what they are not. They are a placeholder for a potential value that you don't have. So you cannot evaluate that it's equal something else. Otherwise, because that's false, right? It's not the same necessarily. I don't know. I cannot say this.
Yeah, I understand what you're saying. What Marinho was saying is that from a very first impression perspective, that will make our equality checking more complicated. That's what
No,
he
it
he
is
was.
true, which is
No,
true.
what I'm
It's not
actually
complicated.
saying is that if you consider no to be a value in and of itself, which it effectively is, then making no not equal to no breaks your equality algebra. Like
Yeah,
your
but no
How
is
equality
do you
not a
say
value
no?
here. That's the thing.
I
In
mean,
relational model, I don't think no is considered a value.
it's it actually doesn't exist.
Yeah,
It's total absence of values. It's
yeah.
empty.
Yeah, it's kind of the same principle, Marinho, of the maybe not talk. You know what I mean? It's kind of that in here. So it's
oh, because you can't like because you have your roles are actually place based. You can't have a role with
Yes.
fewer fields, so you have to have something there. So no is
Yes. So the
yes.
actually what
no, yeah. So no is that's why no is absence of value because the absence of value is the absence of a fact for a predicate. So you cannot judge. That's why it breaks the algebra.
Yeah, that's what Magetta meant there. Anyway, let's
right.
continue here.
So just to be clear, I'm going to frame this as if we were working in Lua, because Lua actually has sensible semantics for how new works in collections.
Ah, okay, I didn't know that.
So I will even omit because we're not gonna do this crap. So just ignore it.
Yeah, I was very surprised that you typed not new there.
Yeah, man, I just type it. I have a macro in Emacs that if I type a SQL thing, I just press it and then it already completes with not null because
That's investment. That's
no,
the
but
name of
seriously,
that.
I see no reason to add nulls on any database. I see no reason. I mean, there might be implementation parts on like, I don't know, SQLite, for example, it has some weird stuff.
I
But
like
like SQL Server, I see no reason to do
I can
that.
see a reason in if you have a hard deadline and you don't have the time to remodel
Yeah, yeah, okay, but to design it properly and everything, they just break the relational model. Like,
yeah, I
let me give you
understand
an
that.
example.
I understand that.
If you know that there is an absence of a value, the correct thing to do is to break that in another attribute in six normal form.
Yeah,
If
I
you
understand
allow
that.
to be null, then you're coupling, not coupling, you're, man, I hate this word coupling, but anyway, you're joining, let's use this. You're joining two tables together, and then why does that break the relational model? You now potentially have two things. Potentially, no. In this case, you would have two things that are different, distinct relations that vary. Do you know the? I think on the talk I mentioned about functional dependency
Yeah,
and joint dependencies, right?
yeah,
Functional dependencies they are like this: directly to the key. Do they have any dependency that is functional that is direct to any other value in this field in this row? So, for example, uh, uh, the document here, let's consider in this case this crazy stuff, then it would be functionally dependent on the other two.
yeah,
So, but it's actually the opposite because these two, they, like this case here, the primary key, the key of this thing, relationally speaking, the key of this thing is these three values
yeah,
because these are amalgamates the other two. But think of a case where you have something that depends like I think the classic example that people give is the you have a company and then you have employees and the employees have children and then you want to catalog the children of the employees whatever and there are employees that have no children there are employees that have multiple children whatever
yeah,
or telephones right so these examples why they work it's because they are relying on this principle that they have uh uh oh man I was just reading the chat uh okay so and then join dependencies there are dependencies that are like this they are dictating how the behavior of something but they are on a join that is they are broken in another table so
yeah,
you are actually doing cross reference to things and not automizing everything to what they need to be so six normal form is crazy because you would have one attribute per each thing I can show you the anchor modeling let me send here maybe we can even list there anchor
Wait,
modeling.
so six? normal form, you have one attribute per table, basically.
You
Like putting it in a
yeah,
very rough
ultimately,
manner.
actually you can have three, right? It would be uh the attribute, the which is the key, and then possibly like the only reason why that's relevant it's because you would do time, right? So you put time on there as well.
Right,
Yeah,
right. You
yeah,
put time on there, like
yeah,
And
time for
why
insertion in the
just
table
time,
and
right?
valid time. Yeah.
Because you want to log the capability of change, the possibility of change in the other in this attribute in specific. Let's say that you have one attribute that you know that changes more than another. Like let's suppose that you have a table like user, whatever, and then you have one value there that the user changes consistently, like sporadically, right? Like I don't know, age. Think of this. Uh, you could automate this, but let's suppose that it's like the user has to go there and update his age, right? Some bullshit like that. In that case, uh, let's say you want to keep track of the all the changes the user made to this field. Then to track that, you would instead, if you update the entire thing, the time will reset and it will be okay. Last modification was on this time, right?
yeah,
But then that's not the modification of that field. What if they modify the name, for example? Then you don't know which one, you see? So
yeah,
to distinguish the and that is a joint dependency. So you would break that into two, and then you have the time mapped to one because there's a different distinct there's a difference between the time for this age and the time for the name, let's say.
yeah, yeah, yeah.
And
I
anyway,
see.
just an example. It's hard to come
That
with
sounds,
good examples, man.
that
Yeah,
sounds very similar to how the atomic works.
yeah,
Yeah, the
actually.
atomic works based on this actually.
Okay,
That's a
so
talk
let me
on
check that
YouTube.
link there.
Anchor
Wikipedia
modeling.
Anchor modeling.
Yeah, this is beautiful.
Okay, let me put this on the screen for the recording. So, Anchor modeling is an agile database modeling technique suited for information that changes over time, both in structure and content.
Yes. Man, like I can attest because I did this in production.
You
With
did
six normal form.
Anchor? Oh, 6 normal 4?
Yes.
Did they
And
allow you to do that? Don't answer
no,
that. We're
I
recording.
mean,
Don't
no,
answer
no,
that.
no. Okay. But anyway, it wasn't an old project. But the point is, I did this. It stayed in production for a few days. Uh, and then the best part is that changing in a environment that changes the requirements all the time, if you atomize all of this, it's trivial to just adapt to whatever people want because you don't have anything. It's easy to compose uh, like the decoupling method on the relational model is the view. So you can just aggregate things in a view, and then everything is just inner joins.
Yeah, yeah, I remember that from back in the day.
So you don't have like left joins, for example. I mean, you might have it depending on the logic, but in this case, just to aggregate components, just to render them as a whole, like a person and all the context, the closure of a person, then it's just inner joins,
Mhm.
and it becomes trivial to just add new stuff. It's really nice. But anyway, whatever. Okay, so this is one example. Now another. Uh, we can add this, right?
Unique age, name, document number.
Yeah, something like this. So unique is another constraint, right?
Yeah.
But notice that unique is a constraint that is not ranging over only these values here for this row. It's ranging for all the rows.
Columns.
Mm. Yeah.
So, for
Oh, yeah.
example, you
All the.
have
Yeah. No, no, no. It's all the rows. That's a important difference. It means, Marinho, that if that rows cannot be the same ever.
so this
Oh,
here.
okay.
If I
That
try
makes
to
sense.
insert this, money. Anyway, just suppose this is your ID and everything, your age. You were born last year, Lemus. Money as well. So if I try to insert this again, oopsie. Man. If I try to insert this again, it would fail, right? But only because it has the knowledge that this already exists.
Wait. Okay, that unique thingy, that completely breaks my idea, I believe, of how to implement it.
No, no, it's just you're literally saying, okay, this table is actually a set of tuples, and each tuple contains an age, a name, and a document number, and the document number has this additional constraint on it.
No, yeah, no. On the higher level, not, in understanding that makes sense. But while Mageta is explaining to us, I'm trying to already go down to the implementation details. And I was thinking, if you allow me, Mageta, my idea was to the constraint, adding constraints to a table when you're making a create table will be a field in our table structure, and this will be a list of functions, my friends. Each constraint is a function.
Oh, we can start those. Yes.
And then each constraint is a function that always receives the self, right? So if you remember correctly, we have a self,
The
which is the
row.
table. No, it's the entire table, the entirety of the table. And then
Mm,
each function, each constraint,
depends. What is the table? The data or the
the logic.
schema?
I was talking about the schema first. Uh,
Yeah.
Before you mention this crap, when you mention this,
Yeah, because on this case you need the data. Like you have to.
exactly.
Yeah.
So you're gonna have to make some sort of mechanism to distinguish between constraints that are
Yeah,
only
this
on
it
like
could still be on your way, but memoized. The problem is if you have like 1 petabyte of data, it would be 1 petabyte plus the 1 petabyte memoized, right?
yeah, that would suck. But I was thinking about each constraint being a function, and then we would have to develop some elaborated mechanism to distinguish between
And
logic
I still
constraints.
think you can do something like that. We can do two kinds of constraints as well. That doesn't really matter. One constraint gets just mapped at insert, right? And the other, updates too, upserts, let's say. And the others could be just functions, right? So we could make a distinction between them too. But here's one thing to bear in mind. Um one of the things that we need to do later is paging. So I'm not concerned about how we're gonna make it fit because well that would be bad, like just deriving the thing. But I'm trying to be smart on later. So what I was thinking is something like this. We have right now because I remember inserting this the role ID. Do you recall?
Yeah, we have row IDs and we jump and we do the math to jump them.
Yeah. So every database that I know, every RDBMS, every relational DBMS, stores this way. It has a row ID, which is a incremental value for this position, this physical position of the row in the disk. Why is that relevant? Because when you go to the disk, you need to multiply by the offset and get directly the data, right?
Yeah, yeah.
So you would have the tree, a heap or whatever, some clustering, some indexing that would result you into a calculation of this offset that would point you to this row ID. And then pointing to this row ID, you do the calculation and you get the value already without doing kung fu's in the disk, right?
Yeah, so
Uh,
let me explain a little better for Marinho. Marinho, the row ID is basically what allows us to write this into the disk, and then when you like persist the data, and then you open the database again, and you want to add a new row to the same table, we need to know how many bytes to jump. We need to do the math, and to do the math, we need to know this guy. That's why we need it. Okay, go on, Mageta.
so okay, so okay, why am I bringing this up, right?
Sure.
I think it's easier. This particularly for the primary key, but we can do this for the others too, right? So what I'm thinking is the following. Uh, primary key, we store like primary key this unique blah 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 this. You see, like a literally like a hash map because then we can do the set constraints.
Wait, I'm very confused. What is this mapping? What is this mapping to?
So, for example, the primary key would be a hash map. Like you pick this value, get a hash map, and then you get a value that points to a row ID. And then by default, the primary key would already be an index because you can literally multiply this by an index by the size of this, the size of this, right? And then you go directly to the disk and fetch it.
Wait, I'm very confused. The row ID tells us how many rows we have, no?
No. The role ID is like this.
It's just a very fancy way of saying this is an index into an array, basically.
Yes,
Uh, that's not
it's a
how
row.
our row ID works, Magit. Let me
Oh,
tell you
then we
that.
did it wrong.
Okay. Okay.
Then we did it wrong because it's basically this.
I mean, that's not gonna be hard to add, but okay, so the row ID is actually not the total amount of rows. This is each
No,
individual.
it is both because on the end, uh, I mean, you can infer it by this, right? It's keeping track of it, but each row should have its own row ID.
That's exactly the difference. Our current implementation is only a number per table
Oh, okay.
to do the
So we
math.
should, yeah, got it. So we should store. I see. To get the last offset, right?
Yeah, to get the last
Yeah.
offset,
So
yes.
we should store in each row, uh, the row ID they
Sure.
belong as well.
Sure, that's
By
fine.
the way,
Actually, or derive it, right?
Go on,
Uh,
Marie.
I know I mentioned Lua earlier, but just because of that, there's no reason to do one base counting, man. That's gross.
yeah, we don't. I think we could do something like we have the size, right, and the total amount. We can just divide, and then go one by one. But we need to keep track, like on my think, okay, on my design. Uh, we can totally ditch this and do for something better if you find a better solution. I just don't have one.
No, but I
But
didn't hear the complete explanation because I was confused on what the you meant with by this, but now
but
it's clear.
something like this, for example, you can make this a hash, right? So for the primary key, you can get a hash, or I don't know. I don't think you would need a hash, right? In this case, so you hash this, and then on the map, the result would be this. On the
Uh,
unique, you could do something similar. I'm just trying to find a common case for all this stuff, okay?
no, that's fine, but
So
I have questions still. So what do you mean by having a connection between a primary key and a row ID? Because in my understanding, the primary key is one of the fields in a row. No?
the primary key is one of the fields in a row, but it's also an index by
Wait.
default. That's what I meant.
The primary key is also an index.
Yeah, because it's unique, right?
Ah, I see. Okay, okay. So
So if
you're
it's
okay.
unique and you know, like why not just go in the disk and search it? Like
Yeah.
you can disable that, but I don't know why you would.
Yeah, why would you do that? No,
Yeah,
I
but
think I
did you
understand.
get this? Did you get why this is similar to the unique and the set constraints?
Not yet. I'm not there yet. I'm just want to understand. So what you're suggesting is for each primary key, for each primary key, which this in this constraint we're gonna have this value as a primary
I
key.
would ignore primary key and focus on I call it set constraint, which is do you agree that to validate if the primary key is this thing you're inserting is valid, you would need to iterate over all the records that you have ever inserted in your life and see if you have anything that is equal this guy.
Yeah.
So that sounds bad. I think I agree with that.
So that's why you're hashing it.
So if we can hash, which we need to think of how to do this hash, by the way, because
Oh,
well,
probably there are some
with
libs
a
to
reasonable
that
size.
do that. There's no fucking way.
No, the problem is the size, right? We need to increase this if needed. But anyway, the we need to hash, and then by hashing, we already handle this commonly between primary keys, uniques, and any other constraints that we might feel like adding on here. Oh, by
Okay,
the way, one thing that I think would be nice adding, like a check that you can do by sets as well.
can you give me an example of what you just said?
Like check and then function check if no uh, person with age age. In this case, it's quite the garbage, right? But if there's
uh,
So something like this. So it would be true if there is no record on this table inserted with a person of age 5, and then it would allow you to insert
What is
something
the
like this.
benefit of doing that instead of just doing like,
Oh, because the first time you can insert.
wait, what? The
On
first
this
time?
case, the first time there will be nobody, so you could insert. The second time you wouldn't.
Ah, okay, so this is a lot more. Okay, so this is also on the data.
This is also on. I call it the set constraint because
Set
it's
constraint. Okay, set
yeah.
constraint.
Oh, do you agree the difference, right?
Yeah.
This is the local constraints, and this is the set constraints. So for the set constraints, I think this works.
Okay, so I actually like the name. So set constraints and local constraints. The local ones, I think my idea works of
Yes,
doing a list of functions.
yes, I agree.
I think it's gonna be very Lisp, very interesting from a Lisp perspective because I think we're gonna have to use backticks and commas and all that crap to make the function, right?
Yeah,
Because the
probably.
function cannot be evaluated ever from outside of of the context of the table because we're gonna use the names of the fields of the table, so we need those.
Right.
We're gonna use probably some metaprogramming thing, but I want to go back to the hash thing. So these are for the set constraints you said, right?
Yes.
Okay, so you are grabbing the constraint primary key, which has this value, and then you are hashing it, okay? And then each one of those will be mapping a hashed document number to a row ID. Is that what this means?
Yes.
Okay. And how does this does the set constraints? Can you explain it or repeat yourself? Sorry.
Uh, so the point of this is just a validating. So for example, let's pick this one here, the unique.
Sure.
Uh, you can make a hash out of these, right? Out of these
Sure.
values,
Mm-hmm.
and then you can just grab by default the row ID. That's pretty simple. But it starts to get hard when you have this kind of case here, the check of the with a function call, right? Something like this. So how do I think we would need to do that? Uh, first of all, this function would have to do the thing itself. So it would have to do some sort of select on this kind.
Yeah, that makes sense.
So this case, it's fine. We don't need to incorporate on this thing. But for the cases that are checking the uh, like
Uniqueness.
primitives, let's call it this way. Primitives like unique, primary key, foreign key, this kind of stuff, we can do this. Non null. Uh, yeah, not null. It would check all of them as well. Actually, non null would be a local, right? So never mind. Uh,
But I'm still confused how this.
yeah,
Uh,
I think so. How this?
wait, I think I got it. Okay. Okay, so let me try to explain to you and then you confirm if I got it, okay?
Okay.
Okay, so let's suppose that I'm adding a new row to my table and I am purposely using the same primary key that is already persisted in the table. Okay, it's already
Right.
there. So the way that I'm gonna do that, the way not that I'm gonna do it, the way that the quote unquote engine would check to not allow that to happen is it will apply a hashing function to the field document number of the row that I am with the intent of adding,
Mm-hmm.
and it's gonna do a lookup in a imaginary hash map,
Yeah. If
and
you don't find anything, you
it's fine.
insert the row ID.
Exactly.
If you
Exactly.
already found it, then you disallow because it already exists.
Okay, I got it. I think I got it. Okay, this is clever though. I'm very.
I'm not sure if that's clever, but
It is
well,
clever
that's
because this is also indexing, right?
yeah. At the same time, yes. And the fun part is for anything that we choose to do like this, that is of the same nature of these primitives, they are already indexes by default. So
Yeah,
that's
that's
one
pretty
of the
cool.
games with
That's
this.
pretty cool.
I will have lunch, dinner real quick.
Sure,
I'll be
go
right
ahead.
back in like 10 minutes,
Okay,
but
we're
go
gonna
ahead.
try to no keep the computer on though. We're gonna try to start making
I'll
the local constraints.
follow you.
Okay, I'm gonna try to. Uh,
Can you move? Just try to move, see if I'm following. Okay, I am. Okay, I'll be right back.
Marinho, are you still there?
I'm still here.
Okay, so here's my pitch. Okay.
Oh
Uh,
wait, Nathan has a good question that we're gonna check. I'll read when I come back.
what about collisions? We are fucked about with collisions as far as I can tell. We are also doing work on being
Yeah,
able to switch hash implementations without breaking compatibility. Is there a problem if some deletion breaks those set checks? Um, um, yeah, you can have a function that checks if you have at least one with five, right? And then if you delete it, you're gonna have maybe a problem, right? Is there an easy way to use some kind of trigger for every change on that set? Yeah, those are very good questions. Go on, Mari.
I forgot what I was going to say.
Sorry for
If it's
that.
important, I'll remember it later.
Okay, here's my pitch. I want to hear your opinion on my idea, okay? About the local constraints. These names are great actually because we will be confused which constraint are you talking about. Uh, I want to talk about the local ones because the local ones I think is the ones that's gonna work better for our case. So I thought I don't know if this makes sense, but I thought on doing the following. You can see the screen, right? You can see my get screen is still there, right?
Yeah.
Okay. So, which reminds me, we need to add a contract for this guy. This guy only works for tables. But anyway, so I was thinking about adding a field called local constraints here, right, in the table, right?
Okay.
And a local constraint would be a vector or a list of functions, okay? And every time you do an insert of some piece of data, we're gonna pick the data that you want to insert and the definition of the table. So each constraint would have to have the skeleton of this. So it would be name, constraint name, right? It would have to receive the table and it would have to receive the data the row that you want to insert. So this will be the 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 shape of each local constraint.
Okay.
And then you would type down whatever you may want to check. So for
Yeah.
instance, you do a let, and then you can check. I don't know. You can get the fields out of it. So you can do something like table fields table, and then you can check the data of those fields and check if the row has some sort of constraint with them. It doesn't matter. My idea is these will be backticked, so then we can use the names of the. So then this would be stored as like data, and then only when you add a new row uh, from the user's perspective, right? Because this is from the definition of the table perspective, okay? So you are making the table.
Okay.
You're doing exactly like this. So you have a create table. In our case, it's just calling the table constructor in using the of the struct. You have fields and they have types as we have in here. And now you're going to have another thing, which is constraints, right? So this would be on the which time are we talking, right? This would be on the table definition time, right? Table definition time. And then you would run all the constraints from the collection of constraints every single time you do an insertion of the data. So as an example, we have in main, we have these for instance, right? So this is basically writing rows to persist rows of the table programmer. So, but and this would throw an exception if you're not respecting any constraints, or one of the constraints, right? So that was my idea. Go on.
Okay. So you want to store code um, on the disk, which okay. We will have to worry about how to serialize that as well.
Yeah, that would be that.
But
That's another discussion for another time.
but I mean that shouldn't be too different from storing a procedure, right?
Yeah, but we don't know how to store a procedure yet. That's also a thing, right?
Yeah, fair.
So that's actually one of the things. This is where we're gonna kind of write down to the disk code. Code I don't know if it's gonna be Racket code. I don't know if it's gonna be
Uh,
MagetaQL code.
Lemos.
Go on.
So yeah, I think the biggest thing to think about there is regarding how far can you go with this code? Because if it's something like, oh, okay, we have those like bytecodes, those are commons you can use in those like start functions. And then from a language perspective, you can just like call functions from a library that you use only those, and then
Your
you can
microphone is weird, man.
start
Can you speak a little
this.
bit louder? Nathan?
I was changing the microphone.
Okay, so
Is it okay now?
is it still not the same one you usually uses, man?
That is something. Wait a second.
I'm pretty sure this is
What about
webcam
now?
microphone. No,
It was.
it is still the same. You're not using the headset?
I am. Well, now I am. Uh,
Is the audio the
well,
same for
let me
you,
just.
Marinho?
Yeah, he sounds like I don't know. It sounds kind of muted, like kind of far away, I
No, no,
guess.
but last time you talked to him, it was like this.
No, he
Y-
was louder and easier
Yeah,
to understand.
yeah, there's definitely a thing going on there.
I can try to fix that later.
Okay, go on.
But oh well. So that's the thing. In that way, you have like some specific commands that can be just stored as some specific bytes, like some kind of byte code. Then you can like make the thing really work with interrupt, right? But if you are planning to store some arbitrary racket code, how would that work for well, using the DB with other languages, right?
I don't know if I followed. If the code that we are writing down is Racket, it's okay because the server is in Racket.
Server.
Yeah, this application that we are building, these things here. So, read schema from disk, write schema to disk. These the user will never touch because this will be on the server side. What will the user see? The user will type MagetaQL on the client side, on the front end side, and it's gonna send the MagetaQL to us. We're gonna somehow convert it to whatever the low level implementations of those are, and it's everything in Racket from now on. So then we do whatever the user asks
Oh,
us to do.
so let's see if I understood. So Rocket will be some part of Magenta QL because,
No,
like,
no,
for
no, 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 no.
example,
No, that's a second step. What you're asking is how the heck the user will type this, Nathan. The user will type this something close to this or
okay,
whatever. But these type of stuffs and this type of stuff, we're gonna have to in my proposal, we're gonna have to convert them from the language point of view, MagetaQL, which is I'm comparing to this, with Racket. We're gonna have to convert those.
wait a second. So okay, you have a
Uh,
server and you can communicate with him like using SQL, let's say,
Yeah.
and sure, you have the things there, and you can connect some kind of client besides the terminal one, like typing SQL directly.
Yeah.
And by that, you can do some stuff like write some Racket code that you transform in SQL and send to the server, right?
No, no, it's the opposite.
Uh,
You write
that's
SQL.
backwards.
Yeah, it's backwards. You write SQL always. The user that is using the client only types SQL. And then the server will receive that stream of data. It will do some sort of magic, which is the prototype is kind of here. It will do some sort of magic to parse that down and convert the Racket to the implementation that we have in this case in Racket. That's
Lemos,
go on.
Lemos, are you ready to have your mind blown?
Go.
What is the name of a program that converts one language to another?
Well,
compiler.
a compiler.
Yes, it's a compiler. And what are you proposing us to do? You're proposing us to write a program that converts Spaghetti QL to Racket. So You
Yeah.
want us to compile MagetaQL to Racket, effectively.
In this proposal of how to implement constraints, I don't see any other way. If we go this route of having a list of functions backticked, I don't see how we're going to do it not compiling. So,
I
uh,
guess we have another language project then. RacketowerDB is now a compiler as well.
but anyway, Nathan, did you get it?
Uh, yeah, kind of. But if it is what I think it is, then it sounds a bit pointless. Well, a lot really pointless. Because I was thinking it was the opposite. You would write arbitrary racket and you would start that. But you are just writing
But that would be the
SQL,
easiest
so it
route
is
possible.
limited. Uh,
Nathan, what Lemos is doing here is he's being lazy. Like, we have a compiler slash runtime already, which is the Racket compiler and runtime. And what he's proposing is instead of coming up with a new runtime or whatever to execute
oh,
those constraints,
okay. You don't want to
we just
design the
reuse Racket
bytecodes and
because we
interpret
already have
that.
it.
Yeah,
Yeah.
exactly,
Oh, okay.
exactly.
Okay, I see it now.
We could do what Marinho said and make a whole thing on top of MagetaQL itself. We could do that. Uh, but I just want to reuse Racket's runtime. Well, maybe that's not the call. That's not the right call. If it's easier to actually make a runtime from scratch based on MagetaQL stuff, maybe it's possible, but you're gonna have to interact with Racket anyway because the things are already in Racket, right?
I mean, you could write an interpreter for MagetaQL, but then you would have to store the AST anyway, so why not just use Racket in the first place?
Yeah, exactly. We could, because if we just say, screw it, let's make a runtime for MagetaQL, then we don't need any of this. We can just make an interpreter and fly on it. But we are already using Racket to make it work.
Wait a
So
second. Racket's compiled,
It is.
it is.
so the database app, it is a compiled app, so it will be there like some binary
Yeah,
running,
yeah,
and then okay, you send some kind of procedure for him to start.
yeah.
So how will you glue this code together? Like it will be Racket like source code there, and you will somehow spin up a Racket interpreter together with
No, we're gonna
the
do
B
something
like
worse,
it's.
which is calling eval on top of it.
Oh, but yeah, you need Rackets somehow, like in the DB.
Yeah,
That's the thing. Most Lisps have their own compilers as part of their standard library, so that's not actually a problem.
No, what I mean is the DB, the app, the binary will have a Racket in it, like
yeah,
a Racket interpreter.
yeah,
Like
yeah.
that's the really bad part, I guess.
No, man, it's not. Like, you're in a Racket environment, you have eval, which calls to the compiler and runs your code. Actually, it may interpret it occasionally, depending on if it decides that it's actually faster than compiling and running. But anyways,
Oh, oh, okay, I see. So since you have like the interpreter available in the language itself, eval in this case, so you just compile eval. Oh, I see.
Yeah,
no,
we
no. What I mean is eval. What it does, strictly speaking, it looks at the form it's given, and if the form is complex enough, it may decide to compile it on the fly and execute compiled code. But if it thinks the form is simple enough, it may just execute it straight up because it may be faster that way.
No, what I
But
mean
yeah,
is,
eval does include the compiler inside of it.
no, yeah, but I was thinking, how can I say, that you would need something, quote unquote, apart. But since you have evolved in the language, you're
yeah,
not
yeah.
needing a
If
Racket interpreter,
if
but you're calling evolve what
but
in
let
what
me
was compiled,
but
right?
let me make myself clear here. If we didn't have evolve, then you were right. Then you would be right. We would have to glue not a Racket's compiler to the application. Like they would live as separate binaries, and one the DB would call the other within the program. But that's not the
So
case
things
here.
evolve, right?
Yeah, exactly. But that's not necessary here because Lisps usually they already come with this with the eval, which is considered to be evil in most communities, but we're gonna use it anyway.
No,
Uh,
I
Okay,
mean,
but
for this
that's actually
particular use
pretty
case, I
good.
don't really see a problem. I mean, you're storing some code, you may want to retrieve it and then execute it later, and the proper way to do that is with eval, so I don't see why not.
Well, that is, it could be a problem if you were doing some arbitrary code, but since it's SQL that is constrained, then converted to Racket, that's not a problem, right?
yeah.
We're not
Okay,
storing arbitrary Racket code.
so let me actually go back here. I want to see a thing. One second. Ooh, I think I see a problem, my friends. I think I see
Hey,
a problem.
do you have a function available to compile? Like, you give me a var in this expression, I can compile and have like the bytes.
Like an explicit compile as opposed to an eval that may or may not compile your code before running it. I think there is actually. I haven't actually messed around too much with that part of the standard library, but I would be surprised if there wasn't.
Okay, but here's the thing. Because now we're going to this idea that I'm proposing. It's very unnatural to me because I'm not very used to do a lot of backticks and commas and tildes all the way through. So try to see if I make sense. Okay. So I was thinking about something like define. Then we do a function that we're gonna call check constraints. Check local constraints because this is not set constraints. Then this will receive a table, and this will receive uh, yeah. For now, let's say that you are receiving the rows just for now, because I just noticed that we don't hold the rows, right? We never hold rows. That's the thing. Like we have a row here, okay? We have another row here. That's okay. But we never have a data that is on memory, a data structure which is loaded on memory with those rows there. We never do that yet. We don't have that yet. We only go straight up to the disk. That's the only thing we know how to do. We don't have like read rows from the disk. We don't have that. Okay. So we're probably gonna have to do that before going through to this idea because well, it is kind of required, right? But let's suppose that we already have that. So let's suppose that is already the data structure that holds rows, right? And we are sending the table. So my idea was we're gonna do a let. And then inside this let we're gonna have some fields. So we're gonna do table fields table. Okay. We're gonna and why we need the fields? Because these constraints are on the fields, local constraints, right? So local constraints are on the fields, right? And something important, because in the beginning I thought about adding the local constraints to the fields themselves, right? So I thought about adding them here. But then I noticed that we can have fields that talk across each other, right? So we have this field, the document number, and the document number uses the name and the age, which are other two fields, to make its own constraints. So we actually need to have them in the table level, not in the field level. Um, Okay, but then you're gonna do this. So you're gonna grab the fields from the table fields table, and then what is the next thing that you're gonna do? You're gonna do a fold, right? Because now you're gonna grab the constraints as well. No. Oh, I don't have. So this is not indented. So I need to. Yeah, it's here. It's here. Okay. So then you're gonna have constraints, and then you're gonna do table local constraints table. Okay. And then you're gonna do each constraint is gonna have this body here. Constraint name, uh, fields. I don't think it needs to be the table actually. Fields and the row, right? So each constraint is gonna be like that. So that is my idea. Then, so you know each one of these functions are their type signature quote unquote is like this. So what you're gonna do? You're gonna you're gonna do a fold throughout all the constraints, right? And you're gonna pass the fields to all of them, right? and
And the
you got
row as well.
and the row as well. So that's my idea. I don't know if this is
Really?
gonna work at all, but it is my idea.
Let me see.
Okay, Magette, you're here, right? So we
Uh,
need to discuss a few
you
Yes.
don't
things. Go,
you don't
Mari.
really need a define for that. You can just use a lambda, I guess.
Sure, that works. I don't have my shortcuts. This, right?
Yeah.
Okay.
Oh, by the way.
No,
So
no,
explain
it
what
needs
you're
to be
doing.
the other fields because fields with I is a keyword in Racket.
Oh, you're kidding me. Oh, yes, it is true. Yes, it is a keyword. I recall that. Oh man, this
Uh,
is horrible.
no, no, let's go like this just for the sake of explanation. I want
But
to talk
wait,
to you
wait a
about other
second. Like
things.
when you do a lambda, oh, it will overwrite, right? I
If you
got it.
do a lambda, it will shadow the outer scope.
Mm-hmm.
Okay, but I want to talk about one point that Nathan brought while you were at dinner, Magita.
Okay.
This idea that I had about transforming each constraint to a backticked function, that would imply that when writing MagetaQL in this file, we would have to convert this to Racket, right?
Right.
So this is now a compiler.
Yes. Yes, I see what you mean.
So when Nathan brought that up, I said, yeah, that's kind of what I meant, but now I am not sure if this is the way, right? This is the way that I thought about it, like right, but I don't know if this is the way that we should go with it. So I want to know what are your idea? What about you? What do you think about it? About that?
Let's think about this. Mm. Oh, by the way, I was reading Nathan's comments. They were good questions. I will reply in a second.
Yeah, yeah, yeah. That's okay.
So here's the what I'm thinking. The I mentioned that we would have a state, a step rather, that is basically the only thing concerned about performing the actions, right?
Mhm.
So in a sense, it is kind of really like a compiler in that sense, an interpreter, let's say. So we could. I don't see anything stopping us from delegating this task to that part. You see what I mean? To the executor, runner, whatever you may want to
I
call
don't
it.
know if I got it.
So do you agree that we are gonna have like can you, okay, explain to me what is the problem that you guys
No,
faced
I'm not.
just now? See
No,
if
no,
I
no.
got it.
We didn't face a problem per se. We
No,
just
okay,
we are just noticing
preemptively.
what would you gonna have to do slash suffer in order to make this idea happen. So Nathan brought the point that if we decide to go with backticked lambdas for the constraints,
Mhm.
we would have to convert MagetaQL language to Racket language, which means making a compiler.
Oh wait. Oh, I see what you mean. Like converting the pseudo SQL, right?
Yeah.
Yeah, makes sense.
Yeah,
Uh,
I
But
was brought
here's
that up.
okay, but still goes back defaults to my point. We are going to have to do some sort of interpreter anyway. Uh, because do you agree that you have the step that you need to execute and do actions uh on the before committing the stuff to the not before committing, you can commit before, but uh like to before modifying the actual data on the disk. Do you recall that when I explained on the steps?
okay, wait. Repeat the last part, please.
So I'll explain. Let me see if I can change the way I explain. So you have a few steps, right? So the
Mhm.
first one is you read the code, blah blah blah,
Mhm.
and you need to compose an AST.
Mhm.
And if it's something like a trigger, a procedure, a function, or even an insert, we're gonna have to interpret this,
We're gonna have to do
right?
that. We're gonna have to do that.
Yes. So my point is on the executor, which is the last part that interacts with the data, we're gonna have to do that anyway.
No, no, no.
So
I agree with you. I agree, but none of what you said that we talked about before, like inserts and creates, none of them would reach the level of a compiler, right?
Oh,
They
if we
could,
want to do
they
functions, it
could.
does.
No, but this is the first time we are considering
Interpreter.
generating functions, Magita. Maybe we talked about it before. Like maybe we brainstormed how we're gonna do procedures or whatever, but we never actually
I
did it.
no, but man, my point is we will need to generate an AST anyway. So I don't see how hard it would be to just generate some actions based on the AST.
No, for me it's fine. Again, I don't have a problem with it. I'm just asking you if you are aware of what Nathan said because it's a good point. Maybe there is another way. I don't know. I don't. I'm not. I don't know this very well. This is just an idea that I had.
Yeah, there might
I
be
mean,
another way. I just don't have any.
Marinho, go on.
I mean, this solution that Lemos brought up, um, it's basically saying that okay, we need an AST to do stuff on the backend based on the query.
Mhm.
Racket has an AST. Let's reuse it.
Yeah, that's kind of what I said.
So you would want to use the reuse the AST in Racket, which makes sense. Oh, that's Lisp, right? But we'll still need to translate between the two. We need to do some transpiling,
Yeah,
right? To
transpiling,
between both.
exactly. But I completely agree with Nathan. And now you just said it. We're gonna have to do
Oh,
transpilation.
unless we
I
just do the
really don't
compilation
like
in
that
Racket.
word.
Wait, go on, Marinho first. You said something.
I really don't like the word transpilation because a compiler is a program that translates a language to
No,
another.
yes, I agree.
So
It
what the heck is a transpiler?
I think it's just to make it explicit
But
that it is in the case transpiling to a high level language to
yeah,
another high level language.
yeah, exactly.
But that's still a compiler. There's
No, I
nothing in the
know, like
rules of
Fable, for example,
Yeah,
that's still a
Fable, Fable.
Maybe
compiler, but
even if
it's
it's only
clear.
because that's more specific, is
Maybe it is marketing
how can I say
dudes.
it's not preciseness.
Yes,
Like it's
in
arbitrary what you consider
in the
a level language.
categories, for example, in the categories of Aristotle, he defines that the things have a genre and then things have a species. That's the same hierarchy. A species belongs to a genre, but it is more specific to define it with a
Yeah, yeah, yeah,
by the
yeah,
feature instead.
yeah. But I understand, Marinho, that we should try to enforce that. No, we should try to make explicit that it is a compiler, but like Mageta said, it is a specific category of compilers, which is high level to high level. That's the only detail. Okay. Anyway, Mageta, you said something with
I
Marinho,
do
and
think there's people that are ignorant to this idea using it that way, though. But anyway, which would make it a valid complaint. But anyway,
wait, what you said about what?
I do think there's people who misuse the term out of ignorance. So I
Ah,
think it
okay,
makes it a
okay,
valid complaint.
okay.
But
I also think that. I also think that.
so anyway, the
Okay, let me explain my idea then. So, my idea, Mageta, is the following: each constraint will turns out to be a lambda function. Okay. So, for
right.
instance, the unique one, right? The unique one, you're gonna do a
By the way, can
fold.
you?
Go.
By the way, you're making a lambda lose lambda, right? It's
Yeah, this
not.
is just for example. This is
Yeah.
just the brainstorming. This is not.
Okay. Okay.
This is the only loose for that. And I don't even know if the lambda will be like this. This is just an idea. So the
Mhm.
lambda will be the translation of the constraint. So in the case of the unique, for instance, you're gonna have the rows and you're gonna have the fields. Then you type down which fields you're gonna want them to be combined in combination to be unique. So this is where the transpilations, the compilation will happen, right? You're gonna have to translate this stuff to to a lambda, to a lambda. Okay. Then, assuming that we have this functionality already, the function that will check the constraints would look like this. So you have a table and you have the rows of that table. Then you grab the fields out of the table, you grab the constraints out of the table, and then you do a fold throughout all the constraints, starting with false, which means that We
Well, if it's going to be monoid, it needs to be true, right? With an
yeah,
end.
yeah, sorry, I was wrong. This needs to be true. So you start saying that it is okay, like you are constraint respecting the constraints, and then you do a fold throughout all each one of the constraints, passing the fields and the rows to each one, and you're gonna execute. This is how we do in Common Lisp, right? But I already forgot in Racket, of course.
You just pass the constraint as the first argument. Like you don't need a fun call. Just put the constraint at the head of the list.
Okay, so you're gonna do like that, and then this lambda will return true or false depending if it is checked according to the constraint or not. And that's the idea. That's my idea. The hard part is how the fuck we're gonna convert each one of these things.
Yeah, that's another story.
No, but we need
Uh,
to think about that because maybe it's gonna be completely like the peak of impracticeness, right?
I would
by the
say,
way, Lemos, the function you want is not actually foldel, it's endmap.
and map, and map then.
what? Oh, end map, it
And
already, you don't need the true, I suppose, right?
yeah, cool. Thank you, Marin. Go on, Mageta.
So, okay, what about we freeze this part that I think will take much more effort and go back to the parser and the lexer and add the first two, the unique and the primary key. Let's start with the primary key and then we do that because I think we can finish that today.
Okay, that's fine. I have a question for you though. Let's suppose that we start making the parser again and the lexer. That's okay. To what we're gonna convert those things, or we're gonna not gonna do that today?
Uh, to what we're gonna convert?
Yeah, because remember, let me go back to the language.bracket here. Remember, every single uh, process of the parser that
Oh, I
matches,
see.
you're
Yeah,
gonna
we're
convert to
gonna,
something else, right?
yeah, on the language Racket, we have sort of a AST that is unfinished. I think
Yeah,
we have a file AST, don't we? Oh, you were editing that.
yeah, I was adding to here because the table is here. The table is this guy.
Let me see what we have here. Stop following you. Right. Okay. Because here's the thing. We need to make some sort of a high level expression. I think I'm thinking if we should make a high level expression and just make the language,
Orbits around that, right?
yeah, or just by statement, like a list of statements.
Yeah, the list of statements is the one that we started the last time. So if you go back to the parser lecture, we started by going create something something
Yeah.
something, create relation identifier, parentheses, attributes, parentheses. So we started with statements. But then we stopped when we
I
identified
have
how
the
the heck we're
feeling
gonna
that,
make conditions for the where clauses.
yeah, you need to incorporate others. That's why I think the because SQL is based on top of COBOL, which is a
Ah.
very bad idea if you think about it. And anyway, it is based on top of COBOL. I have the standard here, by the way, the book.
Nice.
Uh, so the weird part that I think might bite us on not doing with expression, just doing statements, is that I think it will grow considerably in cases. Like, why do I think the SQL got very bloated right on the definition? Because there's no high level expression based. It's not an expression based language, and I kind of understand why. But I do think it's kind of an excuse because, okay, let me go with pieces. So, do you agree that if you do expression based, you don't have to define a lot of the combinations of things that you can do? Like,
Yeah.
you can do wheres, like because where is an expression,
Yeah.
and you
Yeah.
can you can have these expressions loosely, right? Where blah 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 blah. It
Yeah.
wouldn't make sense, maybe because where alone, if unless you have the values correctly, it makes no sense, right? So I think it has this benefit in clarity uh, in what you intend to do in a clause. But on the other side, like just going by statements, you have to exponentially increase the amount of cases to handle because now you have to account for things like, let me type here. Things
Which is
like
actually a thing that we should consider because we have the freedom to make whatever in the query language. So we could actually transform the statement based SQL into something expression based.
so you can write this right
Let me check where you are.
on the constraint SQL.
Here, go.
So insert into values, blah blah. You can do this, right?
Yeah,
Like ABC, whatever, ABC, and then you can put the values here.
yeah,
But you can also do this: select blah into something like this, whatever, and then it would pick the you would pipe this output here. You see?
yeah.
So this kind of stuff that I think you start to have, which is you need to combine terms, statements to generate other statements. I think this gets more complicated. So
Oh yeah,
what do you
that
guys?
sounds more complicated for sure.
So what do you
No,
guys
to me
think?
that just looks like function composition. I don't see what the big deal is.
No, 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 no. You don't get it. They are not treating the things as like expressions that can compose with each other. If you what Mageta means, Mairin, when he says that they did it by statements, it's like this. Like you have a hard mode that you need to match, and sometimes it's very long. Okay. So, for instance, in this case, we
Like a
don't
hard
have,
coded,
yeah, hard
actually.
coded thing. So when we are saying here
Oh.
that you have a create and then a relation,
So
it's not like,
so the case we can compose if it's by expression, right? Because the expression will have a meaning. So
well,
for
at least
example, you
more
can do
easily composed. Because if SQL is statement based and they can compose, that means that they did the work. They suffered, right?
sure they I mean they can compose some stuff like a select, but it's not because it's expecting an expression like that. It's because the output of the thing matches with. By the way, SQL is typed, so people forget about this. So it does have a type checker that allows you
Yeah,
to.
yeah, yeah.
So it knows that a select is the same shape that it's expected on the other thing. So you could do a select on a table, you could do a tuple, or you can do whatever.
Yeah.
But still, like if we're doing that, we need to do. I don't know how to do, man. Like,
Yeah, I
if
also
it's
don't know
by
how to do.
expressions, I think it's much easier for us to compose stuff. But
I agree.
I
I
still
agree.
think it looks like function composition. It's just, except of just a straight composition, like the output of one into the other, there's a type check in the middle, and if the types don't match, it silently puts a drop in there.
No, if the types don't match, I think it doesn't run at all. I think.
yes, it doesn't.
So it's not
Oh,
gonna try if the type checker says no. Which I remember pretty very clearly in my mind
I
when I
mean,
did that read that
yeah.
wrong back in the day.
That let me think of another example, man. It's hard to think of. Like, okay, I'll think of Postgres, I guess. Postgres, you have a for, right? A for loop. You can pick the for loop. Let me open some random code here. I think I know exactly where to look at. Temporal by temporal. So there's this library here. A friend of mine is working on. Let me paste the link here. So
Okay.
he's working on basically adding bitemporality. Like most libraries in Postgres, they don't add bitemporality. They just had one time. Uh, the system time and the which is transaction time and user time, and people just add the system time. So he's adding
and,
both.
and
Uh,
just having the system time is dumb for epistemological reasons.
and like system time alone, like it tells you logging. Like that's it. It doesn't tell like it's transaction, right? So okay, it's useful to have it, but what about the user constraints? You can't express them. So most of the libraries, and I understand why, because to do that you have to do a bunch of attributes, a bunch of functions that are not defined in a SQL standard. Funny enough, no, I think they are now. I think they are on the SQL. I think they are on 2011. But like till this day, I think Postgres didn't merge anything because, well, it's hard, right? It's not easy
Yeah.
to modify a. Ah, let me open anything here, man. Just
Anyway, I
example.
think, but here's my idea. Here's my idea that I would like to propose to you. I don't think it would be very in terms of having a milestone to finish today. Although you are here for like 1 hour and 20 minutes, just in brainstorming. And I'm not complaining about that. I'm just saying that I think we should at least make a proof of concept of this idea of having backticked lambdas.
Oh,
Like
we can.
because it's kind of sounds easy, right? Because this is the function. This is the function.
Oh, we don't even need the parser then, because if it's like gonna be hard-coded functions, we can just mock. Okay, this is a function that we know that maps to a unique or a primary key, whatever.
Yeah. So for instance, we could just do like, for instance, let's make an example of a constraint here. So um, um, do your example. So age field, and the fields is a hash, right? So we can do a
Yeah.
hash ref of age and searching for that field here.
Oh, so you're gonna hard-code the fields too. Okay.
No, just for now. No, I'm not gonna hard code because remember, this is gonna be generated compiling MagetaQL. MagetaQL will generate this that I'm writing right now.
I don't know why the language has my name, but okay.
I know because you started by you coined it and I'm just reusing it. That's why.
I was mocking it, but okay.
And then actually the age one is enough for the check, né? You did a check there. So let's continue with that
Yeah.
example. So let's say that what the field has a value, right? A field has a position and a type. A position has a field and a type. Mm.
Oh, I don't know the new structure. Let me see.
Oh, we don't know. What I'm doing is not correct because we don't know what the shape of rows is. So that's actually a good thing to go through. So Mageta, if you go to main.racket, man,
Main.racket.
you're gonna see that we don't hold rows per se. We have individual rows like here, but we don't have like a list of rows or stuff like that. We don't hold them in memory. We only put them persist them down to the disk directly. We don't have the
Mm,
read rows from disk, you know. We don't have that.
right.
So
Yes.
we're gonna have to make that abstraction. So what do you think? I don't know. A list?
So let me think here. The row, we need to have a row thing because when we load on the page, they need to be composed somehow, right?
Yeah.
So I agree. I think we should make some kind of
Okay.
type for them.
Wait a second, man. Wait a
Let
second.
me look at the book here. Just give me a sec.
So this is not it actually, because a field doesn't know its own name, right? The field knows its position and its type.
Oh, we could. There's nothing forbidding it from knowing.
No, yeah, we could, but I'm trying
I
to
mean,
think.
what if instead of just having the fields as an argument, why not the table schema? Because that has all the information we could possibly need.
We can throw the table, but I don't know if we need the entirety of the table.
No, I don't mean the data. I mean just the schema.
Yeah, the schema. This is the logical table. This is this, right? And the table has a bunch of fields. It has an identifier, a row ID, a fields, and local constraints, right? You were suggesting for each function, for each constraint, each lambda constraint, instead of fields, we pass the table. That's what you're saying, right?
Yes,
Let me
yes.
follow you because the
I
string is
I don't
different.
know. I don't know what's the benefit of doing like that. I really don't. I really
You
don't.
don't fall into the trap where you need to know the field name and you can't get at it because it's on the table and not the fields.
No, no, no. But the field name doesn't. No, this thing doesn't come from here. This thing
Hmm?
comes from here, right? You type that down. You typed that, right? So there is a field. This
Oh,
function.
right. I guess that actually would need to be a part of the compilation process then,
Yes,
because
yes, yes. That would need to be part of the compilation process. Yes.
Because at
Uh,
compile time, I mean compile time of the QL into Racket, we need to figure out what order the fields are in, which will be just the order that we read them, right? And then we have to translate the names into positional access.
Yes, that is correct.
I
That's what
don't.
I was talking
I
about.
didn't follow. Can you repeat that, Mario?
Like when you read the create table, right?
Here.
Yeah, um, because effectively we will be building the table, right? And then
Oh, let's
during
write
the
the
table construction, we will need to to add the constraints, right, to the table, to the schema. Which means that as we are reading, we have to keep track of the names of the fields as they appear
Oh
in
yeah, yeah. We're gonna have to keep
the
track of
query
that.
language, right?
Yeah.
And if we do that, we have a mapping from the name, like written out as a string, and its position, which is just the order they appear in the create
yeah.
relation.
Hmm.
And
Yeah.
then in the lambda, wherever we are building the constraint, when we see a name that refers to a field, instead of putting the name there in the lambda, we just put the field position and just look it up in the row directly.
I think I got 98% of what you said,
The
but
last part
yeah,
I
the
missed.
last part I
Okay.
missed as well because for me, uh, well, I
No, I
mean,
mean instead of what I mean is instead of having that hash ref the fields and then get the age, what you do instead is okay. I know that age is the fields index 0 because that's the order. It was the first one that we saw when we were
Right.
parsing the language. So instead of doing a hash ref, we just do a ref or a vector ref, whatever data structure rows end up being.
oh,
And
okay,
instead of
I
putting
see
the
the problem.
string name, we just put the number 0 because that's the position of the age in the row.
Yeah, but that's the thing.
Yeah,
I'm not
but
no. Wait
we
a
need
second, Nugget.
something to know, right?
No, but that's the thing. I think that Marinho is thinking that we're gonna do what he's willing to do in Sal, which is to parse eval this in a single.
No, that's not really a
Oh,
parse eval. You're
wait. Don't we
parsing
have the
the
position
relation.
stored already? We do, right?
No, we don't have the position stored already. That's the thing that you
Are
said
you
about the row
sure?
ID. Yeah, the row ID in the table is
No,
the
no, no, no. Wait. On the didn't we have something like I remember we had at least on the initial design we
what
had something like on the field we had the field
position.
attributes. Yes, we had position. Yes, here. So this.
Yeah, actually, you're right. We to get the position, to get the number that Marinho is
So
talking
we
about, we
could.
can just do like this. So you just go here and you pick age position, then you're gonna do field position age field.
Yeah.
That's
Hmm.
it. So then you have the position of the age. But what Marinho is talking about, which for me is still like Sal, is like we are parsing these and then we have some things in our runtime, right? So we can have a counter in the runtime, for instance. So
No, what I mean
this
is
is zero, for
like
instance, right?
yeah, that's 0, and then name would be 1, and then document number would be 3. And that's the positions of each field. And while you are building the lambda uh, quotes, the quasi quotes, for the lambdas that you're going to store the constraints, while you're doing that, you will have to parse the QL anyways, which means you have to see the fields, which means you know their positions because you already saw them. So
No, you can do it like that, but I think that approach is harder for me. So the thing that I'm doing is just like, let's suppose that I parse this already. I already have this parsed and I already have the table in my database. So I already created a struct with these fields, right? So I'm doing this from the point of view that I'm gonna assume that every single label in a constraint in a local constraint is a label from of a field. I'm assuming that. If I'm assuming that, that means that these things should not fail because if they are fields, that means that I already have them stored in my table. But you could do what you said. You could start parsing these and you can have some context and then you can put labels and numbers on them. That could work. But for me, that's harder to do at the first glance. I prefer going Grug way first. I prefer doing Uruguay first. Um, so now my thing is, I think this is gonna be an end map. Yeah, an end map in which we're gonna pick. Uh, by the way, are you guys still there, Marinho and Mageta?
Yes.
Yes, I am. It's just got noisy.
Okay. Uh, so I want to try to replicate in a lambda what this would be, right? What this would be. We have to map the age name of the field, right? We have a field with that name, which is in this hash map here. So this is a hash map of a name and a field, normal, no problem. And then but the data that we have is this, right? This is the data, the data of the rows, right? So these rows. How are we gonna check? Oh, because this is age, right? This is age. That's it. So what we're gonna have to do is iterate throughout all the rows. For each one of them, we're gonna have a list of pairs, right? A list
Yes.
of pairs.
Sir.
And then we need to find the one with the name that we want, which is age, right? And then we grab that. So this is gonna be bounded to a value. And then we check if the value is greater than 0, right? There is another catch that I just noticed that these operators here, if we want to be very pedantic about them, we should type check them, right?
No,
Which
yeah,
means
sure.
that this only
We
makes
should,
sense if the field is an integer.
man. Let's not even consider that now because
We should type check those.
man, like we're gonna have to do a type on the overall type checking, which would be simpler, I think, than what we did on silver.
Yeah,
Much simpler, I guess, but
yeah.
it would still be painful because we have to map and the encoding. So we need to have the ST at least done until then, so we can do an interpreter. And then from the interpreter, we probably can get the type checking, like we
Yeah,
did.
but my thing, it's here. Okay. So actually, to do that, this specific example, just for the sake of see if this makes sense, we can actually do like this. So we have the type of the age, right? Because we are receiving the fields. Let's just change this to fields just for a moment. So we can just do things like type, name, right? We can ask for the name of this type, and then we can just check if this is equal to integer. So integer, right? So
Mhm.
if it is, then we start doing
Yeah,
the check.
I would actually put that type check outside of the quoted
Yeah,
lambda
Sure,
I,
sure, okay.
because
and
the way you're implementing it right now is a dynamic check. If you put it outside of
yeah.
the quoted lambda, it's a static check.
Yeah, but
Just one thing though, like we don't need to do it there.
no, we don't
I
need
mean,
to do it
we
there.
don't need to do this checking at all. Like that's what I mean. Like this is just to validate the idea, right? This is
Yeah,
outside the scope of the.
this is just to validate the idea. But Marinho is right. And you are right by consequence, Mageta, which is that we don't need to do it like this. I think we should think about where we're going to do that, because if we do static
Okay. Yeah.
checking, which is doing before the lambda the check, that's going to put extra stuff on the level of the compiler, right?
Just one thing, man.
No, I mean,
Go on, Mageta, sorry.
I'm thinking like when it just made me worry now because when we do the type checking, we need to validate if okay, that's not impossible. That's pretty okay actually. So we would need to have some sort of closure in the table with the knowledge that the field we are passing through right now has this type, so we can check if the check clause, which is on the same object, has makes
but
sense.
the table has a list of fields which know their type and position. We already have the type, it's in the
But we
fields.
won't have a table at that point, do we?
Yes, we're gonna have it in the way that I'm doing. We're gonna have a table at
I
this
mean,
level here.
we might, but that's not necessarily uh, not necessarily we have a table, because you might be defining the schema for the first time. Yeah, you might be defining the schema for the first time, and then you can't look at the table. So you would need the type checking to rely only on the tokens and the AST to generate that.
Wait, I'm confused. Can you look at this thing? So what you're saying is that
Like on line two, you would need some sort of closure, like passing through the type checking. Because I was thinking of how to do the type checking based on the schema, and I don't think we can because the first time you define this relation person, for example,
no, but
how
that's
do
the
you
thing.
know?
No. Wait. That's a very important distinction here. What you're saying, which is like, oh, when we are on line two, we don't have the logical schema table yet because we are on line two.
Yes,
What I am
I mean you
doing.
might, but
No,
the
no, you
first time,
might
no,
if
right?
this was invented
If
before,
this
right?
was create, yeah, yeah.
Yeah,
If you're altering the table or
yeah.
something.
But that's the thing. That's the thing. What I'm doing here, just for the sake of simplicity, I'm not saying we should do that. I'm just thinking it like that because it's simpler for my monkey brain. Is that I'm gonna imagine that we are parsing this. My thought
Um,
process is that I'm gonna parse everything and just don't check the constraints along the way. And only when I'm done, only when I am at this point of the parsing, that I am actually gonna check the constraints. So I already have the table at that point. Maybe the table will explode because the constraints are just stupid.
Mm,
I'm not saying we should do it like that. I'm just thinking it like that because for me it's a lot easier to think if I already have the table because it's just
Lemos,
this. Go on.
Magenta, you were
mhm.
both being silly. You think, and I might be wrong. It looks like you are presuming we have to do this in a single pass, which is not actually true. Like we can do a first pass over over the relation, create table, whatever. We can do a first pass just collecting the field positions and types, and then we will have a table that lacks the constraints, and
Yeah.
then we do a second pass to build the constraints.
Yeah, we could do that,
That's
Magita. It's a second pass compiler. Two pass compiler, sorry. Did you get the idea, Magita?
Sorry, it's muted. But yes, I was thinking of changing the steps, right? Because if you change the, like, let's suppose that you in the same pass you can also do that.
You can.
So
But
you could basically just evaluate and make a schema and then just compose and change the things
no, but
by
the thing is, the
looking at
thing of the
other
single pass
expressions.
compiler is this. Look at this guy. Look at this guy, right? And imagine that these guys are not there.
Not
Imagine that they are
not
here.
there, they're down. Yeah, no, I know, but the point is, wait. Okay, you just moved. Yeah, that
Yeah,
makes
I'm
sense.
no, I
But
moved them, but for the single pass compiler, we're gonna have to put I don't know what is the name in C for these type of things.
no, I
the
mean, it's
the
your
single
building
pass
expressions, right? In the end.
No, you are building expressions, but you don't know what this is, right?
Yeah, but that doesn't matter. It's a symbol.
No, I understand that, but that is a thing that we're gonna have to keep track if we go
I'm
do
not
a
saying we
single pass.
should do one single pass, but no, man, dude. But that's a symbol that you should look in a table of symbols. Anyway, like in a closure.
You're not wrong. You are not wrong. This is gonna be a thing that we. Well, in my
I'm
implementation, you're
just saying
not
it is
you.
possible.
This
It
is
is
the
just
lookup that
trash.
you're doing actually. In the implementation that I did here just for the sketch, I'm assuming that the age is gonna be in the fields. That's my lookup. If this fails, we need to throw an error, right? I'm just assuming. This is just assuming that this exists because the table is already over because we are at this step. We are at the semicolon because I was assuming a two-pass compiler. But if you want to do a single pass, you're right. This is going to be just a symbol.
I don't. I don't. I mean, it's not. It's not like I care. I don't have any reason to do that.
Marinho, you were about to say something?
Nah, not
Nah.
really.
Okay. Anyway, this is kind of what I was thinking about. So look at this. We have we go to the fields of the table, the logical definition of the fields, to check if the integer, if the type, if the name of the type of this field age is an integer. And if it is, that means that we can go throughout all the rows and do that process that I talked about, which is going throughout the pairs, the list of pairs, checking each the one going uh, to through each one of them, finding the age one, and
Mhm.
checking, grabbing this value and doing some sort of condition. In this case, it's going to be greater than 0 and not 5 or whatever. And if any of them are not following this condition, we just return false. Otherwise, we return true. And that is kind of what I was thinking about. Now, what Marinho and you, Mageta, said about doing one pass or two pass, this would heavily change how this works. Um, and well, we're gonna have to think about that. But holy crap, this doing this thing is hard, man. It's so
Imagine,
much to think about.
man, imagine doing
It,
this in C, man.
It's
yeah,
so
The first, man, the first implementation, by the way, of IBM, it was in assembly only. The prototype. Then they added COBOL and C later. But man, just imagine doing all of this without a high level language. I would suffer.
Anyway, so for instance, we there are two options here. Are we gonna do a what, two pass or a single pass? And in which phase we're gonna do the type checking? I think that the gruggiest way possible is to do the checking in the lambda and two pass, which is what I did. That's the gruggiest way possible.
yeah, I think doing two pass, but doing the check outside the lambda is actually it's
Gruggiest.
not that it's the gruggiest because you're failing fast in that case. Because like after the first pass, you just grab the field positions and types. That's all you do in the first pass. And then the second pass, you type check the fields for each lambda you're building, right? Because
Mhm.
the operations you do in the constraints that will end up becoming the lambdas imply certain types, and if they disagree with the types we already know, then we fail.
Well, in that case, actually, in that case that you're talking about, we're gonna be able to just do this because we don't this is already type checked theoretically. So we're just gonna do this, and everything else is nuked. It's just this. You don't have to do any the other things because the other things are basically the type checking. But in the way that you said, we don't need those, so who cares?
Basically, yeah.
Fucking this thing is so hard, man. Uh,
I
okay.
mean, I'm surprised that the Lisper is suggesting we do the checking statically, while the Haskell is suggesting we do dynamic checks. That's backwards, isn't it?
No, I'm saying I consider to do the checking at the same time as the value validation because it's easier to me to just do one lambda instead of two. I'm Greg, I only do one thing instead of two. So I don't need more phases. It's only one phase, everything together in a very tangled stuff manner. So that's why I went with the Lisp way in this case. Because I think that going closer to the ideal way first is going to be a lot harder and dismotivating because we're going to suffer a lot more to try to reach what is less grug. Um, anyway, so a few things that I want to point out. I need to add this thing, right? Oh, actually, we already have this, right, Mageta? You just noticed that this is actually at the position. Oh,
Wait,
no, no, no.
I
This is wrong. This is wrong. This is the position. So this is position one, position two.
no, no,
This
no,
we don't
no.
have.
This is the age. Like this with what we don't have is this.
Yes, we don't have that. So I'm gonna have to add that. I'm gonna have to add that.
Oops. Okay.
Uh, Actually, let's
Uh,
discuss that. If I want to read rows from the disk, let's suppose that I have a function called read rows from disk, and I'm gonna say I'm gonna pass the schema, of course. I'm gonna say which table, so programmer, right? And that's pretty much it. So let's suppose that I have that. Let's suppose that I have the set of rows. What should this data structure should have? Is this only a list of pairs?
wait. Repeat the question, please. Let me
Let's
check real
suppose that I
quick.
have serialized rows, which is the case. We
Right.
already have that. So if you go to the NDF data programmer, this is the data that we have.
Yeah, yeah, got it. Okay.
So let's suppose that I create a function, which we don't have yet, called read rows from disk. And I pass the schema, and I pass which table of the schema these rows are needs to be deserialized, right? Let's suppose that.
Okay.
What is the information that this data structure that I'm highlighting here needs to have? My first intuition is that it's a list of pairs.
So you want the information of the rows.
Yeah, which information we care about? We care
We
about the row
care about
itself, which I think it's this,
the row ID,
and the row ID.
the row data,
hmm
the
Let's call this raw data, right?
I
Raw
think just
data.
that. Yeah,
Just
raw
that?
data. I think just that. I
Okay.
mean, we might later care for other stuff, but for now, I think that's good enough.
Okay. So this is basically a list of pairs. Okay.
And it could be a hash from row ID
Yes,
to the row.
yes. Actually, that's better because then we
Yeah,
can
it
do
could be.
lookups faster.
Mhm. Uh, just to give an idea, the data row structure here. So on SQL Server, it has a status bit. So that's the other thing that I thought about having. When you delete, you don't actually physically delete, right? It is just a ghost. So it doesn't rearrange all the stuff, and it doesn't. It just marks the row as oh,
Alive or
this is
dead?
deleted. Yeah, this is dead. Like it's a ghost. It's here, but we like to think it's not.
Yeah.
Uh,
Okay, that's actually pretty interesting. That's actually pretty interesting. But how do you do when you do the loading? When you load the rows, do you load the dead ones?
no, you
Of course
don't.
not.
That's why they are
Okay.
they, they are just gaps. Like the data is still written on the disk because it's not. There's no point on deleting, right? On actually writing zeros on the binary. But it's as if it's just disappeared. Like
Oh,
it's.
it's only for performance. I thought it would be some sort of backup, backtracking thing.
I would want to say it's just for performance. There's some caveats, but yes, yeah, I think you can think of this way. It is like instead of you going there, like imagine if you delete a very big row, right?
Yeah.
You wouldn't like want to sync because of the other way you can do it async. Otherwise, you would need to sync the writes.
Yeah. No, no, I understand that. I understand.
That's more.
Anyway, go on. You were about to say that we have a field for like status, dead or alive. What else?
We have another status that I don't recall what it is. Then we have some fixed length data. We have the amount of the which is the data, the amount of the row, by the way, the size of the row. Uh, the length of the data alone, not with the row. That is, the row considers the metadata too. That's why. The number of columns, a new bitmap that I don't recall what it is to be honest. A variable offset bytes, which is a column with an offset array pointing to other places on the variable length storage. So the variable storage data, it goes somewhere else because you don't have it fixed, right? So the difference from the fixed length data is that you would have like int, for example. Int, you always know that it's 4 bytes, right?
Mm-hmm.
Int 32.
Mm-hmm.
So you can just store, even if it's like null, it just stores as 4 bytes. It's just 4 empty bytes in that case. Not sure about how it represents though, but anyway. Uh, and then let me think. Any char, that's another fixed length type that you can specify the value. Date, that's another one. So this data they go already on the row. What doesn't go on the row is the variable length data that they have pointers to places that where they actually go to. So for example, if you have 2 gigabytes of I don't know image in a row, like it's not gonna store the 2 gigabytes in a row, right? That's stupid.
Mm-hmm.
You would need like I don't know 10,000 pages just to get one row.
Yeah.
So what they do is that they have a pointer for that on the disk, and then if you want to recover, it goes there and then jams it on the row on the data row together on the display if you request the field, right?
Mm-hmm.
And then the last thing is a timestamp. That's it. Oh, timestamp and version. so you can version the stuff if you want.
Okay, actually I lied. We already have the function that reads the values of the table from the disk.
You said I thought we did. I remember.
No, no, yeah, but we don't have a version of like read rows. We know how to read the entire table.
Hmm.
Wait, no, I think
Oh,
this
but
actually
for
reads
that we
rows.
need to read a row, right?
No, yeah, no, that's what I'm thinking. I think this actually does whatever. I think yeah, look at line 154. So this is the like I already know this top to bottom, so just trust me. This is the end result of this entire function. So this is actually the bytes that remain after we read, and this is actually the list. I think this is a list of rows. The only thing that I'm going to need to update in this function is that I need to add the row ID and return a list of pairs instead of a list of raw rows.
Oh, I see. I see.
Yeah. Anyway, so yeah, pretty interesting. So okay, so let's try to make the next steps of this thing. So first thing, update the read table values from disk. Add the row ID. We need to add the row ID. And what do you think? Should we try to make this concept of the backticked lambda work, Maget? Like, should this be like a proof of concept to see if this actually makes any sense?
I think it's worth doing something.
Okay, so I'm gonna focus on that the next time I play with it. I don't think I'm gonna be able to do this
I
this
think I'll
weekend.
try.
Go on.
I think I'll try. I think I'll try something similar to do it on my own, and then we prove. But let me see. How much time do we have left?
No, we have 15 minutes. Feel free.
Oh, I see. Yeah, it's 22, right?
No, we can go further. I'm
Uh,
just saying that if you
I'm just thinking of the focus here. Let's go to the README, man. It's
no,
better.
the README is gonna say that the next step is like query language.
No, no, I know. Let's just
I
organize it,
mean,
right? So
I mean, technically, if you want to be a bit more pedantic, uh, this work on serializing the constraints is actually part of the query language implementation.
yeah,
So
yeah, makes sense. You would need to parse to convert the.
Yeah, we're gonna have to convert
Yeah.
MagetKL to
I
to
I
to
think we
Racket.
should. I think a way to start is for us to add this kind of stuff, the checks, at least the checks for now on the AST. Do we need to add then? Okay, and we enter the table, right? True.
Wait,
yeah, the table needs an extra field to hold the list of constraints, which
Mm-hmm.
yes.
Lebon's already mentioned.
The table or the field? Ah,
No,
no, the
the
table
table.
needs the global ones, right? Yeah,
Yeah,
the table needs
The
another
table.
as well.
yeah, because the
No, but the
constraints of
field
one
also
field
needs
can
one.
use other fields. That's why. Because when you were at dinner, I thought about adding to the field the constraint instead of the table
Uh,
level.
I mean, it makes sense, but I think that's conflating the scope of the function with to which scope it belongs. Because one thing is to say that it is part of the scope of the like it is part of the scope of this constraint to look at the other fields, right?
Yeah,
That's one thing.
yeah, that's one thing.
And the other thing is physically where do they go? That's another thing.
What do you mean by physically where do they go?
Oh, where you store, like literally on the data structure. I mean, I don't mind, don't matter that much. It doesn't matter that much. I'm
No, no,
just
no. But
thinking
I'm
here.
trying to understand because for me, we cannot do the constraints. This constraint here that you made, this one, specifically this one.
It's because they will. Oh, let me look at where you're pointing.
This constraint is not possible if we only add the constraints at the level of fields. We need to add the at the level of the table.
Oh, what I'm saying is where you store shouldn't matter for this because what will matter is if you can load the fields right to check, which you can.
Oh no, that part I am okay with it. We're gonna load them and we're gonna. That's fine. That's fine.
Yeah,
That's
but
fine.
that's on the scope of the check, not where you store the. I will. I know that's the not evaluated check.
Yeah.
You see the what I mean? Like
Yeah.
the.
Yeah, I think I see what you mean.
compiled check, which is coming from the thing, right?
Anyway, so we added the constraint. So let's try to work on that. And by the way, we only discussed local constraints. Local constraints. Yeah, to do the set constraints.
I
I,
think it's easier.
you think it's easier?
I think
Hmm.
so because
I
it's
don't
just
know.
a hash. Like it's just picking the values that are within the scope of the constraint, which is always just a list of of
No, but
the
you're thinking
attributes.
only about the unique and the primary key. I'm thinking about this gigantic one here.
No, but that is the same. This is the same case as the other. It's something you need to evaluate.
Oh, okay, okay. So this one is gonna use the same mechanism of the local ones.
Yeah, it just happens to be global, right? Because it has to have the knowledge. By the way, you can do here as well. Like you can do something like this. Uh, Tell me a field for a person.
Phone number.
Phone number. Uh, I don't know. I don't know. Let's suppose we have a custom type phone number. Oh, we need to do this too, by the way. That would be
What?
interesting.
Which do
Custom
what?
types.
Custom
User
types.
defined data types. Yes, that would be
Oh. Yeah, that's a thing. That's a thing.
check. Uh, so you can do something like this. It always needs to be true. That's the only thing. But you can do something like select uh true. Anyway, some query here. I'll not invent something, but you got the idea, right?
Yeah, you can make a query there.
So I think the only thing you cannot do is produce effects here.
Well, at least not with common
Effects, I
SQL.
mean, effects, I mean, like insert. Select is an effect, right? But
Yeah.
insert, for example, you can't. This kind of stuff, it needs to be either a query.
I
I mean,
think it
this
needs
is
to be
going
a query,
to.
man. It always needs to be a query if you don't want
Yeah,
to.
it does, but what I'm thinking of what kind of query is permissible because there are some queries that might not be.
Really?
Oh, wait, you consider queries to be just select? If so,
Um,
it's fine. I
no, no,
agree.
no. Well, I think actually, now that I think about it, yes, but I know that the term query means something more than that.
Yeah, query. I call query inserts like everything as well.
Yeah, no, I understand, but we don't. Apparently, only
Yeah,
reading is allowed in terms of side effects. There.
yeah. I didn't think of this, and I didn't read the book. I'll take a look at this, man. I know that there's a funny case on SQL Server that it gets slow if you call a function. Like, why it allows you to call function? Why? Functions they are pure, but it doesn't allow you to call procedures because they cause side effects.
Yeah, yeah.
So I need to think about this. Okay, but let's ignore this case and let's focus only on the
Okay,
others because I
so
think they are fun.
let's keep going. So the list of requirements need to have the row ID on the rows, and we're gonna check. We're gonna try to add a new field to the
Let's
table
add
called.
a let's add like subtasks here.
Okay, so this is gonna be. Let me type it down. Add row ID to row reading from the disk. The next one would be uh, do do a proof of concept using backticked lambdas for constraints. Um,
Then
uh,
also the super ones. Oh, add the constraints to the table.
what do you mean
Are
add
you gonna
constraints to the table? Oh,
Oh,
the
add
field.
physically, yeah, the fields. Just
Uh,
modify the data type.
yeah, okay, so add local constraints to table struct. I want to think add serialization for constraints.
Oh, right. We need to create. Uh,
I don't even
yeah,
want to think about it. Not now.
we're
I
gonna be doing this
mean,
forever.
I mean, if you want to cheap out on it, you can just
Write
use
Racket.
write or Racket. Yeah,
We can just
I don't
write
mind. I
Racket.
don't. Can we cheat on that?
Sure, we can always cheat on
Okay,
that.
I think I have another. I can always cheat. Not always, maybe. I think I think I have another way, but I need to test first. But anyway, just serialization.
Yeah,
Uh,
and then
what
we need
else? I just
to
had something else.
also do the performance of backtick sums for local constraints. Local. And then let's do the same, but for set constraints. Set constraints. I'm actually gonna put the proof of concept before the serialization because I want to be sure, 100% sure before suffering.
Well, not back to commas, just say hashed.
Hashed. Well, I mean, some of
Sh-
them are gonna be hashed and some of them will be backticked, right? Because,
yeah, I just mean broadly. I don't want to worry about the other two now because I
okay,
think they will be more complicated.
okay. So this is the roadmap. So these first two are easy, very easy. This one I think we went a little bit like we have
Oh,
some
there's
drafts.
another one that is interesting. I don't think in SQL you can do that, but there is a thing called uh, database invariant that is an invariant for all the database. So you can do like it's like a trigger. It's not really precise to use this term, but every time you alter, you modify anything on the current scope of the database you're looking at, it triggers the check and then it runs. And then if it anything violates the invariant, then it doesn't allow. It
I think I
locks
never
the
used
check.
that.
I don't think it is available on most of them. I think it's not even implemented on the SQL standard. It's just there's this language here called tutorial D. Let me send you tutorial D, which is implemented in Haskell, by the way.
No, that's
I mean,
unexpected.
it's just a standard, but the standard was implemented in Haskell.
Okay, so assuming that we're gonna do the type checking on on the other stage, we can just YOLO it. So it's gonna be this, and that's it. The checking.
I mean, you're missing the eval on the constraint. Like,
Where here? Eval here.
yeah, actually, open paren, eval constraint, close paren, call that on the rows because
That makes
the
sense.
constraint is stored as source code basically. So
Yeah. Um yeah. Yeah. That's gonna work. And then I can. We just need to make another end map
The-
here.
by the way, the reason for the absence is that you should already specify the invariants in the local level, right? So if all of them are not being violated, then it should be okay. But then that's delegating the some invariants to the code because it would basically query tables, whatever, compose stuff, and then make sure that the database is in this current state that you want, so you can insert. It's one use case, I mean.
That makes
Yeah,
sense.
but whatever. There are more important stuff that's SQL to have than this.
Okay.
Magenta, you're not following Lemos.
No, no, that's not a
Uh,
problem. I'm just doing a sketch here. Mageta, you can show whatever you're showing there.
no,
You,
I was just typing and then you moved.
Row. Uh,
Try to
fuck.
find
Okay, so now we're gonna need. Man, I really need for to do Lisp properly. I really do need indentation. Holy fuck. Uh, so let's see. This is the field. This is the row name. So this is a car on row. That makes sense. Just for the sake of simplicity, I know probably this is not like efficient. I'm gonna pick the row value as well. So um, car of Kadar of row. No, no. This Lisp doesn't do that, so it's not this.
Probably it optimizes, right? I think.
Uh, I hope so, but I don't know for sure. Then um, I'm gonna do if if oops if row name equals age, then true. Actually, it's this, right? It's oh no no. I need to do another check now. That's true. So now I just do this, and now I check greater equal than 0 if row value is greater equal than 0. I'm not gonna do the different. No, does that matter? No, I'm gonna do just like that. Let me just do it like that. And then else. So this is not an if. This is a when. Uh, is that it? So we have a lambda. We grab the row. Then we grab the row name and row value. If the row name is age, we check the value to see if it's greater than 0. If it's not, uh, uh, well, I mean, I don't know. This is gonna return new, right? So I need to do something about that. So let's do just this. So if you're not age, I don't care about you. I don't care about you. Yeah. Am I following this right? So let me see what a row looks like. So a row is oh, I need to do another for actually. I need another fold, sorry. It's a fold within a fold because each row has multiple things inside it. Okay, so that's wrong. So this let here, it's correct, but not on this scope. So I need to do another end map, another lambda, and then the row here, and then this
Right.
lambda
This function is very handy.
end map.
Yeah.
Yeah, it's really handy. Uh, and then the what's gonna be the name of this? Oh man, raw fields, raw field. Who cares? Then I'm gonna do the Control V, which is now correct, and then this is gonna be raw field, and I believe this is it.
It's not matching the parentheses though. Right?
I think it is though. Am I going crazy? This is
No,
closing.
now it is. Yes.
Okay, now it is. Okay, so let's see if this makes sense. So you grab each row. Each row, so we have a bunch of these, right? So you have a list of these.
Right.
So each row is another list. Each list
Of pairs with the
of
name
pairs,
and the
exactly.
field and the
Okay, so
value.
let's see if this is happening. So this is a list of lists of pairs. This is a list of pairs. So each list of pair has what I'm calling raw
Um,
field, which is a pair. Then I'm grabbing the the destructuring the pair effectively, checking if the name is age. So I'm checking if this is age, right? I'm checking if this is age. If it is, I'm just grab the value and check if it is. And because we are assuming this is going to be type checked before, I can just do this no problem. And
by the
if you
way,
go,
the rows, the last rows, like at the very end of the lambda,
uh-huh,
it should be one parent to the left.
one parent to the left. I'm confused.
The last.
Oh,
That
this
Oh,
is
purple
for the
the
end
parent,
end.
map. This is for the end map. You're right. Sorry.
Yeah.
yeah.
Okay, so then if the name is age, I'm gonna do something about it. If the name is not age, I'm just gonna just continue because this is not the field the field that I'm interested in.
I mean, technically, you could do a dict ref instead of iterating over the list explicitly. I mean,
Wait, a dictref? What is that?
there's a generic interface called a dictionary, which is part of the standard library.
Mm-hmm.
And on lists, it assumes we're doing an association list, which is exactly what you're doing. Basically, a list of pairs where the car of the pair is the key and the coder is the value.
Oh, I see what you mean. I see what you mean. Yeah, we could do that. Totally could do that. But I want to test if this works first. So
Okay.
theoretically speaking, this is about it. This is exactly it. and the field is already here. So let's go to main.racket. Let's go here and say
And
constraint
hope I
one.
can run.
Yeah, to see if you can run, yes. And then control V, I guess. Oh, indentation. I don't have
Arrange.
Emacs.
Yeah, that's fine. I think I can indent.
Okay,
Let's
go
just.
indent there. So then when we do the programmer thing, instead of finishing on there, we're gonna do something else about it. We're gonna just say, well, I mean, what is better, a vector or a list? Tell me, Marin.
I need to install the formatter. Ah, man, screw it.
Vector or list? Um, well, if you're thinking about performance, which we may not care about at this point, I would probably go with a vector because it's flat. There are no indirections in it.
How do I
It's
make a
just
vector? Vec?
no. You actually, it's vector. It's like the word vector, and then you just put the
This stuff,
the
right?
the stuff at
Yeah,
yeah.
it's like the list one, but for vector. Okay.
Actually, I think there's an immutable vector you can build as well if you want to prevent mutations, but
Yeah, but for now this doesn't
um,
matter. For now.
yeah,
Okay, now
okay.
is the time. So we have the table.
Wait, you're adding
Oh,
this?
and you want to unquote the call to vector,
Well,
otherwise you're just putting the
Yeah.
wait.
This ends here. Just a sec.
yeah, we have four fields, Mageta. We have this field of the struct, this field, which is the row ID that we use to do the offset, this field, which is the hash of fields, and this field that we just added, which is the constraints vector.
Oh, right. Okay. Yeah, no, the indentation is wrong.
Okay,
Okay.
well, I mean, we don't have indentation tools.
No, I don't mean the that line. I mean the line with the vector constraint one that should have been way on the left.
Okay, so now it should be a lot clearer, huh?
Yeah, that's right. That's actually right now. Okay.
Okay, so that's it. So now what we're gonna do is in here, uh,
Oh,
we're just gonna call the function, which reminds me that we need to provide it because I didn't do that. So here, which reminds me that we should change this provide stuff, but for now it's fine. So save that. And then here we're gonna just do check local constraints programmer table. And that's it.
let's comment all of this because I think it will
Sure. Just
eat a
just
lot of time.
yeah, but just yes. That.
Yeah.
Wait, is the closing parents? No, it is correct. No, it is not correct. We did
Oh,
something
the
wrong.
module. The module.
Oh, the module. Okay, so there is another parenthesis there.
Then just
Oh,
remove
that
that.
reminds me. You're using a full del, like a straight up full del for the constraints checker, right?
No, I'm not using a folder.
Which
I'm
is
using the end map for both here.
well, you're using the end map, which means actually it's probably better to use a list for the time being, even though it's
Okay,
not ideal because
okay. But
I'm
later,
pretty
but
sure end
yeah, but that's
map is
implementation details. It's fine.
Ah,
Okay,
okay. Can I
Mageta.
run?
Yeah. So open
Ta-ta-ta-tam.
well, you are on a Mac, so I don't know how does that work.
Oh, it doesn't work. That's the thing. So it's
Just
just
build, just build. If you
the
have just installed.
I did. I did install actually.
So
Oh, okay. Just
holy balls!
Da-da-da-da. You're getting there, Lemus. Everything is
Table
met.
error to mismatch expected 4 given 3. So
On
something
where? Let's see. May
something went wrong.
24.
No, May
you
20.
added a new
24
field
is
to
what?
the table
Beautiful.
struct,
Yeah, but
and you
I
didn't
Oh,
use.
wait. On the table.
no, don't follow the error message, Maggot. You're gonna be pissed.
I
Go on,
know, I
Marin.
know. But where did you put the.
Why is it not working, Marin? I added here.
Wait, does
That's
the
the only.
table pick this? Expected.
Let me explain
Oh,
my Maggot for you the error. The error is saying that it's expecting 4
yeah,
arguments to
yeah.
make a table.
That's somewhere. To make a table, where are you reading the table?
Table arity mismatch.
Oh, it literally says here table. Okay.
Yeah. So then we have a table on line 35 that we are creating. Oh, it's because the car table is wrong. Okay, that's why. Thank you for nothing, Racket. Uh,
Oh, the other table.
okay,
Sorry.
now
Yeah.
you can just build and do it
But
again.
aren't we inserting anything on that? We're
No,
not,
because we
right?
commented the rest of the code.
Okay. Yeah, I could just compiling the code means nothing, man.
Okay,
Expect the true
arity
given
mismatch.
one
The
on the checked
expected
local
table. Oh, I
constraints.
forgot. I forgot to add the. What? There are
Where's
two arguments that I added, right? Rows. We need rows, my friends. Okay.
oh
We have rows, fortunately. So list row one, row two.
mm-hmm.
Go.
Compile and run.
Oh man, imagine. Okay, lambda,
Unbound
unbound
identifier.
identifier. Also, no
Uh,
web syntax transforming inbound. Yeah, that I don't understand what it means.
at lambda, it's on your end map. So let's see. Where's that?
What is the order of the arguments in endmap, Marinho?
Order of the arguments. It actually expects to get a predicate. So it's a single argument function. So the order actually doesn't matter because there's only one.
1 second. Yeah, you are completely right. But we are doing a lambda, so this should be fine, right?
Right.
Because look at the error. The error is saying that lambda, there's a problem in there.
No, it's actually saying that the eval is failing because lambda is unbound at the context. Yeah. I think we need to
Oh, I
actually,
see. Could it be this lambda?
yeah, the quoted lambda
Oh,
over
there's
there.
yeah.
It's
Actually,
being
we have three here.
evaluated, and we need
Yeah, let me format this because it's
It's
awful.
unreadable. If there's a language that becomes
Wait.
severely unreadable because of indentation, is Lisp.
Just a second. I want to open on Emacs. Just let Emacs open.
I would say the same for F
Totally.
sharp.
Oh
Uh,
man, actually, there's no salvation. Yeah.
There's no salvation. Tutorial D. Wait, why is this in French? The fuck? Tutorial
There's only a page in French, Russian, and some other language I don't know.
Tutorial D is a
Chinese, I guess.
language for interacting with relational databases. I never heard of that. You
It's
know very
a
very advanced stuff for in relational model, Magit. It's impressive.
big A. That's the word you're looking for.
If
let's
Emacs is open, we
see,
can see.
Nekoma,
procedure,
Magit,
Racket
table.
did you hear
Tower.
me?
Oh, sorry, what?
If you are managing Emacs, we can see.
Oh, yes. I'm just doing the. I'm gonna use Lisp mode, okay?
Yeah, but Marinho, could you help me understand the error message?
Uh, Go back to the place where we're evaluating the lambda, and let's
Sure.
try something there. I have an idea
There.
that
Is
could
it
work.
better? I
Wait,
think it's
I
better.
can't see. Oh, you're talking about the indentation. Yes, it is better. Go on, Marinho.
Yeah, so go back to the place where we're actually calling eval inside of
Yeah,
the,
here.
yeah, there. Uh, I'm going
Okay.
to suggest something that I don't think we should keep, but it may help uh, fix the problem. Um, let me just. I have the editor here open on another tab. Let me just go there. Okay. Um, and I don't actually recommend we keep this like this, but define context to be current namespace, and then we pass that to eval.
This seems very cursed. Whatever you're doing. Is this supposed to work?
Huh? What does this
It
do
might.
exactly?
What it does,
Oh,
it
this is binding. Oh man, is this forcing evaluating like from a function?
Yeah,
I
it's forcing the symbol lookups to happen in this particular namespace
which is
as
empty.
opposed to.
which is just a placeholder, right? Just grabbing the thing.
Yeah, effectively, I'm saying whenever we eval the lambdas, we do this in the context of this module, basically.
Oh wait, this is a keyword, right?
Mm,
Or can you do
it
this in
shouldn't
Racket?
be.
I thought that the to define functions it was with the define like this.
That's
Ah,
not actually a function, it's just a value.
Yeah,
Like,
that's a value,
yeah, but
Mageta.
that's what I'm asking this context because this is not a function, right? The function is like this.
Yes, yes, yes. That's a
no,
function.
yeah, that's a function.
Okay, but I'm still confused. Why would that solve the problem? What you did there?
Because it said that app is unbound, and I know for a fact that app is a thing that Racket binds in its. Okay,
What happened there?
Still,
Wait.
still unbound, I guess.
Is still unbound,
still
yeah. It's
unbound.
still unbound. But for to be fair, this is the first time you're actually trying to use eval in Racket, so maybe there's some shenanigans that we need to learn.
Oh,
Let's
we
actually
No,
tried
there are
search
using
for
definitely
it.
mechanics.
Eval.
um,
let me look here.
uh, we're in main.
Oh yeah, there is a version of eval with what Marinho just said, namespace. And
Uh
again, just plain English. We don't have examples of cursed code. Okay.
First code.
The evaluation handler is called in tail position with respect to the eval call. An evaluation
Huh,
handler uses the current namespace in the two argument case of eval.
I just saw a guy doing exactly what Marinho did.
Whoa.
Yeah, 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 yeah.
Yeah, I didn't find
Mm,
anything. There's a current eval. What is that?
Spare.
Parameter that defines a current evaluation handler. Ah, yeah. DP.
Eval, Racket.
yeah, eval is weird in Racket.
Eval is weird in Racket, my friends.
Eval syntax.
Like, I just searched for eval and apply in Racket, and apparently eval should behave exactly as we expected. I don't know why it's failing. I have no idea why it's failing. Yeah, it's not backtick, it's quote, apparently. Ah, let's
Quote? Like
Oh,
simple quote.
yeah, single quote, yeah, instead
Oh,
of backtick.
what? No,
Yeah,
but
this is in the guy's example here.
like man, as far as I know, the back quote it is to evaluate partially things inside. But in the end, it will be just a symbol, the same way. Want it? Or am I crazy? Or
Let's try
racket works
let, let's
different.
try to do it first and see if it works, and if it works, we try to discover what it means.
So did you modify whatever
Yeah,
you
yeah, I
needed
just
to?
modified, yeah, just modified. Yeah, but in this example that I'm seeing here, the guy is actually doing back quote.
No, I'm bound identifier.
Yeah, it's the same problem. Weird,
oh,
weird.
I think the problem may actually be inside of the lambda itself. Let me try something slightly different. Let's see. We're using. We had a back quote. You tried with a normal quote. Let's try this instead. And then inside of the AST, instead of eval, we call eval syntax.
A
That
length.
might work.
Okay, I have no idea. We're gonna learn if it works. Go on, Mageta. So he added a hashtag there. But do you need to mess around with the Racket syntax system to make
Oh,
that
it
happen?
changed. Contract violation. Number
Expect a
given a
number
name.
given name. Okay, so the lambda is wrong now. This is better. This is better.
Yes.
Before we go
Because
to
it's
that,
logic.
Marin, could you
Mhm.
explain to me why we had to mess around with the syntax stuff for the eval?
Because the problem is that the body of the lambda um, it has basically plain symbols, but it has no syntactic context, which means when you expand the macros, like
Oh,
um,
I think I see.
like and this is actually a bit of a Racket implementation detail, but function calls in Racket are actually treated as if they were macros, and they insert a form called app, like the hash symbol followed by the word app in front of it. But since the lambda was just quoted, there was no syntactic information, which means there was actually no binding associated with the app that would
Uh,
do the function call. And replacing the quote with a hash means that this is now a syntax object, which means it has it has a context associated with it,
mhm.
which is the point in the source code where the form appears, basically. Which means that lexical scoping now works as you expect, which means that eval now produces the correct lambda instead of failing.
Wait. So
Oh,
what you're saying to me is that when you don't use the hashtag, it doesn't know in which scope it's gonna run this crap.
It actually runs in the dynamic scope of the call to eval, which I'm not sure exactly what will be in there because remember, Racket is actually a compiled language for the most part, which means there may not actually be a lexical environment present at runtime. So
I'm gonna ask more questions about this later, but let's try to debug this lambda for the time being.
so
So
let's
Maget,
see. It's saying that there is a violation in the name. Where is the name?
yeah, no, the name is in the raw value. So raw value is wrong apparently. So what I did there, I added a print in the line 31. So the next time you run this after rebuilding, we're gonna see what the
Here's the
heck
thing.
is.
When you do,
uh,
it's like this, right? It's a pair. So
oh,
one
I think I see the problem maybe. Um,
string, what? Bad syntax. Is this wrong?
the problem actually
Oh,
is actually a bit silly. I Lemos, quick question, pop quiz actually. How many equality predicates are there in Racket?
Quality predicates. I don't know what is that.
Equality
Oh,
predicates, like there
equality.
are
I'm gonna
yeah
guess
equality.
3.
There are actually five
you
of
have
them.
EQ. It's
We
not
have
EQ,
EQ.
right? You have wait. You
No,
No,
have
we
they
have
do
EQ.
have
EQ.
EQ. They do have EQ.
We we have
Okay, they
EQ.
have
We have
EQ
EQV.
equal.
There's equal. There's equal always, which is basically equivalent to closures equality. It basically treats immutable values by value and mutable ones by reference. So that's nice. And there's the equal sign, which is the one you used, and that's a specifically numeric equality, and you're giving it a string as an argument, so that's why it's failing.
Oh man, man, you're kidding me.
No, I'm not. And the reason
Type
we chose
classes go burr. Ah.
and the reason we have the numeric equality as a separate thing is because equality of floating point numbers is broken, and it wouldn't be good to have it as part of the equal uh, predicate. So it's relegated to a number-specific predicate, so it doesn't mess about with the semantics of equality for the rest of the language because you have some stupid stuff like none is not actually equal to none, like not a number is not equal to itself.
Oh, that's the same in F sharp, by the way.
Yeah, I mean, if you
Right.
use the numeric equality, if you use equal, I think it is actually equal to itself because equal is meant to be a sane equality operation, as opposed to whatever the IEEE defines for floating point madness.
Okay. I
It
understand.
ran.
I understand why it's wrong, Mageta. I understand why it's wrong.
Yeah, I just don't understand which part is the which field from this.
It's this. Okay, now it's gonna work. But
No, no, but wait a second. Like, which field is this integer 32 value? Like, where is this coming from?
Oh no, no, sorry, I forgot. You're right. I need to
Because
actually
we're the
pause
rows they
past the
are like
value here.
name. Because both rows here they are just strings, right? So what is the integer?
No, there is no integer. This should go false, right? This should no, actually this should go true. This should go true because there isn't any field with
All right, it will
age.
be a bit okay. It's because man, I'm thinking of types because it will compare, right? So anyway,
Exactly. But now let's make a row 5 here. So row 5 will be the one. Will be the one. Uh, so let's go there. So row 5. Actually, remind me. This is a bad idea because we're gonna have to change the table as well because in the fields and stuff like that. Let's actually just change the age to
we
name,
we send the table. Yeah.
not name because we need I don't know. Let's put
Year,
age.
year.
Let's put age, but let's actually add the field age here because the table will not respect that. So let's do that. So age. So we're gonna
Right,
have a
and then you want to
field
add here
position
the
2. This is an integer. Nice. Where is the crap here? So we just do that, and then you say age, and then
so
we
we don't need to
say
do this, I guess.
field
Just put the value.
age, and then we already swapped it. Now we're gonna need to add ages to all of these guys. Well, to at least two guys,
But we,
Yeah,
right?
yeah.
actually, the age
Okay, so let's
here is not quite
pick.
right.
Let's put the number 50 here because 0 is kind of silly. Um,
Oh, wait, it's a data type, right? So we
yeah,
need
it's
to
it's
wrap
a
it.
yeah, it's a data thing. So you need to wrap it. But it's not integer 23 though. Good
Oh
guess.
yeah, it's
Good
correct.
try.
Oh, maybe no Okamo, who knows?
I mean, Zig has integer 23, both signed and unsigned. So yeah,
What? Should
like
I ask
Zig,
what is the point of 23? And it's weird.
No, in
it's
Zig you
for
can make integers of arbitrarily a
A
number
very
of
arbitrary
bits.
size.
it's for packed data in case you wanna put in case you have some data that can fit in a single word and
Mhm.
some parts of it like
I get to run.
like if you wanna have if you wanna have a like three
Oh,
booleans and whatever, like you can actually pack that in an efficient way. Like at runtime, it actually becomes bit shifts on an integer.
I get to run.
And in that case, you may want to have a field that's like 2 bits wide or 3 or 4 bits wide, you know?
uh-huh. Yeah, that
So
makes
that's the
sense.
use case. That's the use case. That's why Zig allows you to have arbitrarily sized integers like 23 bits, 25 bits,
Mhm.
37, whatever number you want. And then it's at runtime, it will obviously, if you need to put that in a variable, it will round the size up, so it's properly aligned. But if you put it in a packed struct, it will actually occupy exactly the number of bits you wanted. So,
That's pretty cool.
Yeah.
so you can have compact data that way.
What's not cool is what is wrong. I'm confused. Read syntax. Illegal use of dot.
He's complaining a dot. Where?
Line 52. So it's saying that the problem is here.
Oh, you're
Oh,
missing a close
right.
paren after the
Ah,
name, actually,
yes. I
after
just
the
saw.
name field.
Wait, but this
Yeah.
is also kind of wrong.
Yeah. Now it's right.
Okay, now it's right.
No, it's still wrong, actually.
It is
Where?
still wrong. Whoa,
Uh,
yellow, yellow.
here,
Oh, there.
and also here.
Wait, but I think now we have more parentheses than we need. Wait. Yeah, now I think it's correct. Now I do believe it's correct. We don't need to care about the other rows, Mageta, just for you to
Yeah,
know.
yeah. Yeah, but if it's a syntax error, you won't
This
parse.
should be
Like,
false, right? Integer 32, value
uh,
undefined. So what am I doing wrong? 1 second.
We need to
we need
import
to eval, right?
the. No, actually, we just need to import the. We
All
need to
right.
import the module that has all
Are
the.
we not importing? Oh, we are not importing it. Okay, that's okay. Require
Yeah, we don't need
Racket
to eval.
Racket Tower DB AST. Okay, so now we should have access to these. Okay.
Procedure
In
in
Racket
AST.
provided by base.
Oh, right, because you
Oh,
decided to call the procedure struct procedure because even though that's already a thing in Racket. So yeah.
yeah, we need the accept whatever. There is an accept thingy. 1 second, Magita. I already found it.
Except I didn't understand. Can you guys explain?
Yeah, too
Oh,
slow,
there
Magita.
Okay.
is. Oh,
There.
oh, right. It's the. It's the. I recall you guys explain this.
Wait, we have problems with parentheses, guys. I think.
Yeah, we do
So
actually. Oh, there's
something.
one less here, Rich.
Oh yeah, now it's correct.
One more actually.
Go.
Dun-dun-dun-dun.
We still
It's
undefined
still
it.
defined.
I'm very confused. Marin, what am I doing wrong, man?
Let's
Is the rename
see.
in only like grabbing the procedure, or is actually importing everything?
It should import everything and just rename the ones you specified actually.
When? Oh, I know why. We need to do this trick here. Okay, my bad. We
Uh,
need to do this trick here. Integer 32. Okay, try again, Magetta.
What the heck is this, man? Struct updaters out.
This is providing not only the struct but also all the methods and the field access and all the crap. Okay,
Okay, so
okay. Attempted to
uh,
use a module that is not available. I have no idea what it is.
module mismatch.
Dynamic require. The last time I saw this, it was like very bad. Marin, what am I doing wrong, my friend?
let's see. Module mismatch. Possible cause. Module. Let's
Integer
see.
32. It has a value. Yeah, I have no idea what am I doing wrong. Absolutely no idea.
Module AST phase 0. Phase 0. Uh,
It is classifying the integer 32 slash value as undefined. So I believe we are not importing and exporting something.
You see here?
Yeah, I see that it is recommending to use dynamic require, but I think that if we need that, we are doing something inherently wrong. Like very, very wrong. We should not need that.
False and integer.
What I don't
Previous.
understand is that we are doing exactly the same thing as we are doing with field, right? And field works in main. Why it doesn't work here? Why it doesn't work here? Oh, we have
let's
two
see.
requires. Maybe that's the problem. Can you try again, Magetta?
I can. No, not sure if that is the issue though.
Yeah, that does make sense to me as well, but who knows?
No.
Yeah, doesn't solve the issue at all.
So let's
So what am I
okay.
doing wrong there?
Uh, module path provided. Ta, 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 ta. Oh, I think I might have seen the problem. If
What's the
we go
problem?
back to the AST, wait, no, that's the AST already, right?
What's
Procedure.
the problem?
Let's try, since we're doing eval syntax anyway, we probably don't need this. And let's try without the context here and see if that changes anything.
What?
Because the context that we were passing here, it actually has all those definitions like procedure, table, whatever.
Go on,
It,
Magetta. I don't think that's the problem. I really think the integer 32 dash value is the problem. Like it doesn't recognize that thing, but I don't understand how that's possible. How is unrecognizing the thing?
let's
What is
see.
happening there?
Same stuff.
Yeah, it's the same. So I think it's in this place here, line 34 of main, Marine. So we have it. We
Line 34.
Yeah, we are grabbing the value, and because this is kind of like we are assuming this is type checked, right? So this
Uh,
integer 32 dash value should retrieve the value field out of this raw value thing,
yes.
and then do the comparison with 50. That's what should do.
550. Anyways, let's see. Map, da, 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 da. Hmm. Technically, yeah, technically the integer 32 value is the only thing in that lambda that's not actually in the standard library.
Oh,
So we may need to actually do the dynamic require anyways.
oh,
Let's
okay. So
see.
the environment in which this lambda is running is an environment which only has the basic libraries. Is that what is
Let's
happening here?
see.
So that means that the requires that we do in our code doesn't they are not inherited by the lambdas when we're doing eval, which makes eval like a little bit safer, I guess, because it has less stuff to mess around with. But now makes sense to have to use dynamic require, right? Because we want dynamically to add another dependency to this
Name
separate reality, right?
effectively, yes. Dynamic require, and we need,
Just pick the
let's
rename
see.
in.
Um,
Did you
it
did
has to
you
be
understand
quoted,
the problem,
right?
Magetta?
Not really.
Okay, I can try to explain again. So the scope, the context in which this backticked lambda is running, is a
Yeah.
scope slash context that doesn't have our stuff. It only has base Racket,
Oh, I see. I see.
which means that in order to tell it, no, 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 the created worlds throughout the backtick lambdas, I also add to them this dependency right here. That's what the dynamic requires for.
Hmm.
Then we have to put a quote here, and
And zero there.
then we have to put a zero there.
Okay, go on, go Magetta, go Magetta.
Let's do some magic.
Contract
Contract
violation.
violation. Expected module path, path index, result module path, and given that.
Module path, which means
I don't want to say anything, but I'm looking at the documentation, and dynamic requires has two single quotes instead of only one.
that's fair. Let's.
Why
Oh,
would they
right,
do that
right.
though? Why would you do
Madness,
that?
I tell you.
Like, I understand wanting to separate which dependencies go to the evolve and which dependencies go to your program. I understand that, but why would you do just double double the thing there?
Okay, I put another quote. Let's see if that fixes it. If it doesn't, we may have to look at something else.
Okay, we need to save
Oh,
the file
wait.
first to go on
Yeah.
Magetta.
Wait. Let me queue. Again.
Let's imagine for a moment. No, same thing, same
No.
thing, exactly the same.
Let me see what those predicates actually mean, and then we can do module path index.
Okay, but we discovered something now. So in order to use this trick of using backtick lambdas for the constraints, we need to get around this dynamic require thing.
We may just have to actually do it, the dynamic require. It may not be something we can work around.
No, no, I'm not saying work around. I'm not trying to run from it. I'm saying that we should be comfortable with it. Be comfortable with it, yeah. So I'm looking at the
Grammar for
documentation,
module
and apparently you can
path
dynamic
or
require
require.
specific stuff from the dynamic. It's basically like require, but just with the dynamic on in front of it.
It's either a root module path or a submod. Okay. And then root module path is either
What happens if you
quoted
put the zero though? Are you
identifier.
importing everything?
No, the zero is. I think it's about the Racket phasing system. Like,
Wow. Okay, so this is like it's remind me of Commander and its compiler macros, man. We are telling in at which phase of the compilation process we are doing the require.
yes,
Crazy.
because you may need to run, like, you have runtime, which is phase zero, I think,
Hmm.
and then you may need to expand macros before that. So macro expansion of the runtime is phase one. But then the macros you are expanding may themselves be implemented in terms of macros, which means those macros have to be expanded, which is phase two. You see?
Yeah, makes sense.
Macros that are written in other macros. Ah.
I think actually we can't do the renaming. Let's
Oh, you
try.
can do the
Anyway.
renaming. Okay, so you're gonna do except. Can we do any other stuff, or we need to do?
No, it has to be a plain module path. It cannot be
But then
like
it's gonna complain about the procedure stuff.
might. We can try it out.
Save the file. Go on Magit. I'm pretty sure it's gonna complain about that. Unknown
Uh,
module. Okay, that's worse. I was wrong.
yeah.
Okay. So what about that one? What about that one?
Maybe we have one too many quotes. That's a possibility. But
Probably.
actually, let's see.
Dynamic require. Well, to be fair, some examples in the documentation actually are using only one quote. Maybe there is a rule that we should actually read, but why not just try it out? Go on, go Magit.
False.
That's correct. That's correct. Now go to the rows and put them above 50, both of them. And now save and run again. It works.
Oh.
It works,
Okay.
boys. It
Man, this
works.
this was very cursed, but but it
I
worked.
mean, we're going to serialize this code, right, at some point. So,
Yeah.
But it worked. Okay, so the proof of concept it works. Now we need to ask two questions. Is it
Mhm.
workable? And second, is there a better way? Those are the
A
questions.
better way, I have no idea. Probably there
but
is
it's
one.
definitely workable, man. I mean,
Yeah,
it just
I
ran.
do think it's good. I don't think it's bad the way it is. We
Oh,
just need. So next session, I think we can convert the. Well, we would have to go back to the parser, right, and finish the ST.
no, we need to define if you're gonna do statement based or expression based. We need to decide.
Let's
Yeah.
go with expression, man. I think it's less troublesome and it's easier to parse.
Okay, so let's do expression based.
And it's easier to compose stuff. Let's,
Okay, so do a commit, please, Maget. You can commit
yes,
direct. Well,
sir.
we should not commit directly to master, I think, but well.
Oh, I'll make a branch.
Okay, make a
Uh,
branch. Make a branch, please.
so let me see.
Constraints. Constraints POC. That's it.
I
Brains.
wonder how many views this one will get.
It's 3 hours long. Probably none.
What the heck, man?
But I mean, we did some magic that should count for something, right?
I mean, if somebody watches two
And to
hours
be
to get
fair, and
to,
to be fair,
to
we found a use case of Evolve that is not that cursed, right? We are not doing just for the sake of doing it. It actually makes sense for a problem.
out of naivete, I think that's what I mean. Which is what we did on the parsing right before.
Yeah.
Um,
But I can believe it. We are gonna be using backticks as like
well,
the foundation, the foundational abstraction for the constraints. That's cool. Because the last
oops.
time we did
Yeah,
this, Mageta, I don't know if you're gonna remember, but I do remember because I was
I
the one
would,
driving
yeah.
all the time. The last time we did a bunch of backticks and a bunch of commas and single quotes, It was to do the error messages for the parser of silverware back
Oh,
in
I
the LFA
recall.
days.
I recall, yes.
That was a headache to understand
Bad
how to do.
days. Okay, I'll open the pull request.
Yeah, I can open the pull
Um,
request just fine. That's it. So I'm gonna
I'll
finish the.
I'll see if I can do by myself the hash as well.
Okay, I'm gonna finish the recording now.